kind of roop, that is the kind of image that we have created, probably in just about all the Jain centers in North America. So both Digambar, Shwetambar, Bhatmas are on the same Vedi. So this is beautiful. I just want to share, my name is Sulekh Jain again, and I want to welcome everyone with a very, very big welcome at Jai Jaininder. And I want to especially share with you that today's this program that for the last 3 days we are celebrating, it has been funded by, in majority, with a substantial grant by Sir John Templeton Foundation. And Templeton Foundation many years ago, with probably $1 billion, maybe more, they started a whole program devoted to dialogue between science and religion. Dialogue between science and religion. So for the last several years, we have been thinking, because yesterday it came out very clearly that there's so much knowledge that has to be dusted off from our Jain scriptures, from our agams. And our Bandaras have a lot of knowledge, but they have not seen the day of light. So this seminar yesterday pointed out, and I think we need to move on that one. We need to examine the material, the knowledge, the treasure that is in those volumes and those granthas critically and rationally, bring it out and share with the rest of the world. So with that, we started several of these programs. And a few years ago, there was a conference at MIT on science and Jainism. Then in this country, during the last few years, I'm going to only 1 or 2 minutes, last 7-8 years, we have established our Jain presence at 25 universities. So, and we are proceeding more and more in that direction. Hopefully we'll get to all 24 Tirthankar plus many, many more. And even right now, as we are talking, 3 hours from now, there is a parallel conference that will be starting 3 hours from now at University of California, Riverside. And they are also looking the antiquity and many, many these treasures. And that is at Jain Studies Symposium 2020 on illness, medicine, and healing in Jain tradition. And this is taking place yesterday and today at University of California, Riverside. Similarly, I want to share with you why we started this journey of Jain mathematics. Next year in March, there's going to be a seminar, Consciousness in Modern Science and Jain Philosophy, March 19 to 21, 2020 at Florida International University. And similarly, we are looking at many of these aspects. So we started looking a few years ago that mathematics area is completely unknown. Many people do not know what we have in Jain mathematics. So there's one guy, my very dear friend and my bada bhai, my older brother, whom I have a lot of respect. He's always an idea man. And not only idea, then he also inspires. That person is Dr. Vimal Prakash Jain, who lives in Boston area. I've known him for more than 35 years. If you remember, he was the director of the Bhogilal Derchand Institute of Indology in New Delhi for many years. And something magic happened there. About 16, 17 years ago, we were starting an international school for Jain studies, and which became a harbinger, which became a catalyst for us to start many of these chairs at many universities in North America, which I mentioned, we have chairs in probably many places. So in his office at Bhogilal Derchand Institute of Indology, we laid the foundation of the International School for Jain Studies. And if I remember, Dr. Anupam Jain was there, Dr. Sagarmal Jain, who Devlo Gaman only a week ago, he was there, and Dr. Vimal Prakash Jain. So with that small seed, we have made a small progress. And today we are very pleased to invite Dr. Vimal Prakash Jain to say a few words. It was his idea a couple of years ago that he said, let's start a conference, let's start a symposium on Jainism and mathematics. So Dr. Vimel has many, many qualifications. If I can just share with you, he has, of course, PhD, Pali, Sanskrit, Jainology, and he's gold medalist all through. He has guided research for 40 years, and 6 candidates have people done PhD under him, and published a lot. And he has given talks internationally at many, many places. And I've known him all these years. He has given talks at Hebrew University in Jerusalem, Stockholm University in Sweden, Lancaster University in England, Manitoba University in Winnipeg, Canada, University of Sydney, University of Rome, you go on and on. So he is one of our shining jewels. And we are so honored that what he started, what he put us 2 years ago, that start this dialogue on Jainism mathematics. We are here. This is a tribute to you, Vimal Bhai, and I want to welcome you and want to invite you to say your few words of wisdom and guide us for future. With that, I present to you my very dear friend, and I call him Mota Bhai, my Bada Bhai, Dr. Vimal Prakash Jain. Jai Jain.
Friends, I hope you can all hear me.
Yes.
Is it okay?
Okay.
Yes.
You can all hear me?
Yes. Very well.
Okay. Friends, Jai Jinendra and good morning, everyone. You have already traveled half the way. Hope your deliberations have been meaningful. Thanks for inviting me to the event. I wish to put these few words on record. Munishri Mahendra Kumar Ji Ditiya, in his well-known work, Enigma of the Universe, thought it wise not to mention the name of Mahavira. I have gone through the text of the Tattvartha Sutra from A to Z. The sutras of the Tattvartha were created with the knowledge of the sacred canon. This is undoubtedly the proof that the canons did contain detailed knowledge of all branches of mathematics, deep philosophy, and yoga theory and practice with the purpose of attaining nirvana. The actual person behind all this knowledge could, in all probability, be Mahavir and Mahavira alone. And then you enter into the very high, subtle, deep and secret, unknowable details of the states of experience, of knowledge and enlightenment, of a bounded universe, and the existence of innumerable independent individual souls. The one who knows all these things in their details, depths, and heights can only be an omniscient person, which Mahavir certainly was. This would mean that Mahavir was a scientist, a mathematician, a philosopher, and a perfect yogi, all rolled into one. The conference, in our view, would then have, without going into religion, theology, and beliefs, brought into limelight that Mahavir was the scientist who invented the theory of numbers, that space is qualified by a boundary, and how compassion has a meaning, etc. And the credit for this goes to Vijay Bhai Mishra. He is the true Brahmin and the true Jain, not me. Thanks. Thanks to all of you very much for your patience.
Thank you, Vimal Bhai, for giving us your blessings 2 years ago and today. Your presence is so important, so invigorating for us. And we want you to be guiding us for many, many more years. And we will keep on doing these kind of the direction that you have given us, that we must do science and Jainism. So with that, in fact, what we are doing is we will be setting up a panel already in India. There are many Jain scientists who are working together to look at very much on this science and Jainism. So we will be producing many new volumes, new research, and probably giving them more and more encouragement in that direction. So we are moving in that. The other person, I'm not taking too much time before Dr. S.C. Agrawal comes in and chairs today's session. I want to invite another very important, I would say, my role model for more than 20 years. And we are following now his footsteps. This is Professor Dr. Peter Flogel. Peter Flogel is an institution in himself. He is the founding chair of the Center of Jaina Studies and professor of the study of religion and philosophy at the Department of History, Religion and Philosophy in the School of Oriental and African Studies, University of London. He has published extensively on history, anthropology, and sociology of contemporary Jain schools and sects, Jain relics, stupas, Jaina, Vaishnava syncretism, and on the socio-political and legal history of the Jain tradition. He is also working on social history and questions of comparative philosophy, pluralism, and nonviolence. He convenes the annual Jaina Studies Workshop at SOAS. He's been doing that for many, many years, and many Jain luminaries, many Jain scholars come there. He's the editor of International Journal of Jain Studies and editor of Routledge Advances in Jaina Studies and Jaina Studies of Horowitz and principal investigator of the Jaina Prosopography Project. And for this project, for this seminar, Peter Bhai, you wrote an extensive foreword many years ago on the 6 volumes on the mathematical sciences and karma antiquity written by Professor L.C. Jain. You brought his work to limelight. You brought his work to share with all of us. So we are so honored to have you today. And we want you to address this for about 20 minutes. Take your time, give us all that you have been doing. And we are following your footsteps. As I mentioned, we are 20 years behind you, but we are catching up very quickly with you what we are doing. So hopefully we will have a lot of fun together. So with that, I want to present to you my friends. Professor Dr. Peter Flogel is coming to us live from London, UK. Thank you.
Thank you, Suleik Bhai. You're over generous, of course, in your praise of our modest work. Basically, we are learning from the Jain community and from the Jain sages. And we think Jainism is part of world culture, world heritage, and it's relevant for everyone to know about it. Now, I'm very honored to be invited to say a few words about this conference. Basically, I'm not the right person to ask to say something about Jain mathematics, because as you heard from the previous speaker, from Suleik, I don't know anything about mathematics, really, and all my work was on other aspects of Jaina studies. And nevertheless, I follow it very closely because I know how important mathematics is for the understanding of Jain karma theory, which of course is at the heart of Jaina teaching. And I'm very grateful indeed that the Jain Center of Greater Boston has taken the step to organize this conference and invited all the luminaries in Jain mathematics. And this is a field that evidently is blossoming nowadays. And I would say it's one of the fields where cutting edge research is being done after L.C. Jain and others have prepared the groundwork for it. There's so many people acquiring the many difficult skills that are required, i.e. Proficiency in Sanskrit, in mathematics, and the history of Jaina literature and philosophy. So this is indeed a field that is highly specialized and not accessible to most of us, and I speak as a layperson here, in other words. My perspective is a genealogical perspective. And from that perspective, from this point of view, I would, of course, like to learn from the mathematicians, Jain or non-Jain, who have tried to understand these difficult Prakrit and Sanskrit texts, which has mathematical content that is not easily to decode. Now, much work has been done already. I had the pleasure to attend a conference on Jain mathematics in Indore in December, and some of the speakers are also taking part in the present conference. I'm always very impressed at the level, the standard of debate. Not just general questions of ahimsa and anikantavada are addressed, but very specific mathematical problems raised. And indeed, a lot of new discoveries have been made in this field. Particularly, Anupam Jain has stepped into the footsteps of L.C. Jain and assembled a group of highly qualified scholars around him. And this is really a fantastic work that is being done there. It deserves high praise indeed. Now, the one concern I have as a layperson is, of course, that the links to genealogical concerns, to philosophy and comparative religion are not as yet as well developed as could be. The debates are very much focused on the interpretation of the ancient mathematical passages in Jain texts with modern mathematical tools and modern mathematical proofs. This is very much in the spirit which you find also in comparative philosophy, where admittedly a minority of scholars apply the tools of symbolical logic to philosophical texts of Indic and other traditions, also medieval European philosophy and so on. Now there is the danger of anachronism, of course, but no doubt this exercise is sharpening our minds tremendously. So it is absolutely invaluable. But in my view, it would be also good, in addition to what is done in mathematics, or mathematical analysis of Jaina texts, of these passages, to present a little bit more of the context, i.e. karma theory, cosmology. This is being done, of course, but I think the results of this fantastic work could be communicated more effectively, say by translating entire texts with commentaries or writing texts on karma theory, where mathematics have been a stumbling block to understanding. So there's a lot of scope for further development, but the groundwork is, of course, to be done first, and therefore this conference is extremely important. And
Peter, can you raise your volume a little bit more, Peter? People are asking.
I would love to lower my volume now.
Or you speak louder a little bit so that.
I'm planning to lower my volume now because okay. I've come to the end of my few words of appreciation of this wonderful conference. I'm delighted that the texts are studied critically, as Suleik has emphasized as well. And so I learned yesterday that Nemichandra made a mistake in his calculations, and this, of course, is very enlightening in every respect, and I would love to hear more about it. Thank you very much for giving me the time to congratulate the speakers for their great work and the organizers. Thank you.
Thank you, Peter Bhai. We are grateful for your taking the time. I know you have been very busy today and tomorrow. You've been also going in the other symposium. So extremely grateful for what you have been doing for all these years at SOAS. You have trained many, many Jain scholars. I know several of them. And so we are in connection. We are connected with them, in fact, and you already have about 3 or 4 people who are doing PhD under him in Jainism. So we are grateful to you. And keep up this good work. And now there is a strong relation. Let's build a very big bridge between the United States and the UK in the terms of Jain academic education. So we need your guidance, we need your help. So keep us, thank you. For many of my Jain friends and others who are in this symposium, I just want to share with you that significantly we'll be devoting our resources to looking at science and Jainism. In fact, I would say Jainism and science rather than science and Jainism. So we'll be emphasizing that. And with that, if you know a Firodia Trust in India, very big one, Firodia Trust, they have, in fact, our International School Jain Studies, it has been now under the arms and wings of Dr. Abhay Firodia, and they are providing a huge amount of resources. I'm talking manpower, I'm talking money, I'm talking places, all kinds of resources. So one of the emphasis will be on the dialogue on science and Jainism. So my request is, humble request to all the people who are in this, those who have interest in this area, please write to me or send me your information. We will create a virtual center and we'll keep connected so that we'll pick up the brains and the information from everyone. And we'll open up many, many avenues for looking at the Jainism and what is there in science and in mathematics, many areas. So with that brief welcome introduction, I want to invite today the chair of the session today, Dr. S.C. Agrawal. Dr. S.C., we are so fortunate to have people who are chairing the session. Dr. Agrawal, he is the officiating Vice Chancellor of Shobit University in Meerut. And before that, he has been Dean of the Faculty of Humanities, Physical and Mathematical Sciences at the same university, Director of the School of Basic and Applied Sciences, Professor and Head Department of Mathematics at Charan Singh. Charan Singh was the former Prime Minister. Charan Singh University in Meerut. And he has gold medal for serving first position in MA and mathematics, MA and MSc in mathematics. And he has supervised 38 PhDs so far, and probably he will do many, many more under him. Published more than 75 research papers, and I can go on and on. He has organized many international conferences on at Jambudweep, at Hastinapur, and international conference, Indian civilization through the millennia, at least 3-4 of them. So his achievements are great, and we are so honored to have today the session chair, Vice Chancellor, Dr. S.C. Agrawal. And we welcome you, and we are so honored to have you today, Dr. Agrawal. Jai Jain. I think you are muted. We have to unmute. Unmute yourself, please. Yeah, you are muted. Unmute. Can you unmute him? Yeah, now he is.
Yeah.
Okay.
So is it okay? Can everybody hear me?
Yes.
Yeah.
Okay. Thank you very much, Professor Sulekhji, for so many kind words and generosity in introducing me. It's indeed a big honor to chair this session. I'm sure everybody is hearing me.
Yeah.
Yes.
To chair this session is indeed a pleasant coincidence, about 35 years back. It was because of Anupam that I started working on Jain mathematics, despite the fact that I was trained as an applied mathematician in IIT Kanpur and then in the School of Mathematics, University of Newcastle upon Tyne, England. Anupam came to this Chaudhary Charan Singh University, Meerut, for his MPhil degree, and he was absolutely clear that he will write his MPhil thesis and PhD thesis only in Jain mathematics. He completed both on the topic contribution of Jainacharyas in the development of mathematics. I remember that his main focus was on Mahaviracharya. We have also written a book on Mahaviracharya, Mahavirachar, a Samikshatmak Adhyayan, which possibly, Anupam can tell more, will be revised before the Boston conference. I am indeed proud of being the teacher, PhD supervisor, and co-author of my very dear student, Anupam. Coming to the present session, I have 6 speakers.
Hello.
And the keynote speech by Professor Peter Flogel has
Hello.
already finished.
I
So now 5 papers are related to the great mathematician Mahaviracharya, and I'm sure Dr. Anupam, while speaking on the treasure of ancient Jaina mathematical wisdom, might also say something about Mahaviracharya. As such, this session can very well be dedicated to Mahaviracharya. It is just a suggestion from my side to Professor Pankajji, Sulekji, Manojji, etc. The success of any session of any international conference depends upon the speakers. When I say depends upon the speakers, I mean that it is my request they keep the time. Each speaker is being given 20 minutes time, as I'm told. We can distribute like this, that 15 minutes for the presentation, and somebody will give the indication that 15 minutes are over, and then the speaker can take 2 minutes to sum up, and last 3 minutes will be for the question and answer. So this is how we will proceed. Our first speaker is Dr. P. Devaraj. Professor P. Devaraj comes from Cosmic Mathematics Foundation in Kerala, and he will be speaking on the cubic methods in Gadit Sar Sangrah. May I request Professor Devaraj to tell about his findings, his research, and about cubic methods. Dr. Devaraj, please.
Okay, thank you. Hope I am audible, sir.
Yeah,
all of you.
to me.
Okay, thank you. Yes, thank you for the organizers for giving this wonderful opportunity. Yes, can we go to the next slide? Yes, so I will be talking about Ganitha Sara Sangraha. It's a vast text, all of you may be knowing that, but here I will be focusing on only one point. Okay, before that, I will just give you a brief about Ganitha Sara Sangraha and Mahaviracharya's great contribution are this mathematics. So this credit of providing sweet and pleasant flavor of vivid poetic imagination to the rigorous logic of mathematics goes to the mathematician Mahavira. Here I would like to comment on this as that, okay, nowadays we talk a lot about the art integration. See here, all of our ancient mathematics texts are compiled in this form only. The beautiful poetic language has been used. And among this, yes, Mahavira was the prominent or the dominant personalities here in this vivid poetic language, those who are used in the poetic language. Okay, and it's another important thing is that this is an independent mathematical text and not part of astronomical text as usually we saw in the Indian tradition. Indian mathematics texts are only the part is mathematics and the majority or the major part or as a whole it will be a astronomical text. So this is one of the texts which we can say is a mathematical text. And after this, if you look at the mathematical text as an exclusive mathematical text, we can see another text of 16th century or 15th century, the Yukti Bhasha of Kerala mathematician, sorry, the Ganitha Yukti Bhasha of Deva is another textbook which we can say it is exclusively mathematics, which doesn't talk about astronomy. Okay, so this is the first text we can say which talks about only mathematics. Okay, and when we elaborate, we can see that after explaining the methods, he gives some problems also. So we could assume that okay, this may be used as a mathematical text for academic purpose or teaching. So that may be the reason. After explaining the methods, he gives some problems also. Find these examples, and we can elaborate when we are discussing the problem also. And as of many of you may be knowing that okay, it contains 1100 shlokas. Okay, can you move to the next? Yes, so in this presentation, I'll be focusing on only the cubing methods which explained by Mahavira. And there, okay, we can see that generally that methods, the algebraic methods, has been attributed to Islam or European mathematician, but we can see that it has been used by Mahavira in 9th century itself. That's what I will be focusing on this presentation. Shall we move to next? So in the brief, Ganitha Sara Sangraha uses these terms, okay, Gunagara or Pratyutpana for multiplication, Bhagagara for division, Kriti for squaring, and Vargamula for square root, and Khana cubing, Khanamula for cube root, and Chidi for summation. So shall we move to next? So here in cubing methods, Mahavira uses two major important methods. That's one is progression method, and the another one is cubical expansion of binomials. So I'll be focusing on cubical expansion, but I will just brief you how Mahavira has given these cubing methods. Next. Something went wrong. Okay, can you try to put it in the next one, next slide? Something got upset. Okay, fine. Fine, something wrong with that slide. Okay, in the format. Okay, there actually Mahavira gave different methods. Actually, he gave 7 methods out of this. The first one is multiply a number with the same number 3 times. That's what the first time. That's all of us know. Okay, wherein we can use this method for small numbers. But for higher numbers, he has given another method. Okay, that gives you x cube is equal to a plus b into a minus b plus b square times a minus b plus b cube, wherein we can find out a common difference or a deviation from a given number so that you can operate it easily. So that's another method. That's also an algebraic way of finding the things. And if you can find out the algebraic expansion, it gives you the cube of the number clearly. So the expressing the things in algebraic way, that was there in Mahavira. Generally, we talk about as many things starting from the other mathematician, but Mahavira also started these things explaining in algebraic way. Okay, now the next way he explained in a progression ways. 2 ways he explained in a progression way. But in the next case, he explained it clearly, a plus b the whole cube as 3a square b plus 3ab square plus a cube plus b cube. This is what we call it as the algebraic identity. Please put it to the next slide. Yeah, fine. So if you want to find the cube of 12, he explains clearly how to do that, this method, the algebraic way. So he says, okay, you can put it the first one cube. Okay, one cube, that is one itself. Then, yes, thrice the square of the last multiple by the succeeding. So here he gives a sutra like this. Andhya Andhyanya Sanakriti Paraspara Sanam Sam Gunadam Triganadhadam Punarevam Tadyogaha Sarvapadan Khanam Dikhadam Prandam. Like that, he gives it. Clearly, he gives this Andhya Pada and Anya Pada. Okay, so Anya Pada means the left hand side. So, like that, from left to right, how we can find this cube of a number 12? That's what he explains here. So, that's clearly explains the 3a square b and 3ab square. Those terms. And finally, the cube of the succeeding. That's the last term. Okay, 2 cube, that is 8. When you correct the place values, we are getting the cube of 12, 1728. So
Dr. Devraj, sorry to interrupt, but we have Dev Bhai online who has the slides looking better than what it's looking now. If you want, we can switch to that.
That's fine. Okay.
Dev Bhai, you want to share?
Yes, I can switch it.
Okay, I'll stop sharing. Sorry about that.
Should we go back a couple of slides so he can go over those slides better? The last few slides, if you want to do that.
The second last. You can put the second last. That will be better.
Okay. Can you all hear me?
This one?
Yeah.
Next one.
Sixth.
Yeah.
Okay.
Thank you.
Yeah, and if you can make it full screen, Dev Bhai.
This is full screen. No,
Presentation mode is.
Should we see next slide?
It is. Yeah, it's displaying second slide with the notes.
Oh, okay. Let me.
Next slide. Yeah, we probably have to display. Sorry.
Give me one moment, please. Okay, can you?
Not seeing this slide.
Not shared yet.
One second.
Good now.
Yeah.
No.
Again back.
I'm making a slideshow.
Yep.
Yeah.
Okay.
Yeah,
Back.
Much better.
Can you go to back to back? Previous. Yeah, fine.
That's a good one, right? That's the one. Cube.
Next one. Yes. Yeah. The product of any 3 equal quantities. That's what. Okay. This was I was explaining. So these are the methods he explained in the slogas. So different ways to solve a cube itself. So that's what we were discussing about the last. Okay, the first was also algebraic, and second, and the next 3 terms you can see that it is summations kind of things he has been explaining. And in the last, again, he is giving this the exact algebraic expansion of our identity. We will call it as identity. Next. Yeah, correct. Fine, thank you. So this is how we can find the cube of 12. So you can start with 1 cube. then 3ab square. That's what 3 into 2 into 1 square. Then 3a square b, like that you can find out. And then 2 cube, the last term cube. So when you correct it, okay, the place value can be corrected and you will get the answer 1728. So this is a clear-cut expansion of this algebraic identity a plus b the whole cube. So clearly explains step by step. There is no ambiguity or no clarification is required. So that way he explained the identity, how it can be used. Yes, as all of you may be knowing, and I will agree that, okay, our mathematicians were focusing on the practical application of the methods. So that's what he clearly uses it. And next. Yes. So as a Sarva Samiksha, or as we call nowadays identity, you use this a plus b the whole cube is equal to 3a square b plus 3ab square, or whatever the order we reuse it, right? A cube plus b cube, all this order may change, but all of you may be aware about it, because I am not a mathematician, I am basically an automobile engineer, and because of the passion towards this ancient mathematics, I am trying to learn and explore these things. And one more thing, see, this is on yesterday also the discussion was there, why we should learn and explore all those things. Yes, the usage in the modern terms is one aspect, but I do these things in another aspect. See, you can see that generally this contribution is attributed to Omar Khayyam of 1050 of 7th century and Blaise Pascal of 17th century. But wherein this has been already there in our Jain mathematician, that Mahavira, great mathematician, gave it in 9th century itself. So when we talk about this, it really inspires students and it motivates students. That's what I do. So that really helps in the pedagogical area and the academic area. So nowadays we focus a lot on when it comes to mathematical education, mathematical phobia, or the what you call the negative impact or the students. Yes, they are moving away from mathematics. But really these kind of contributions and its awareness and the story of mathematics and history of mathematics really can motivate the students. That's what I feel it is a major important or the key factor in this. That's what I'm doing it. Okay, yes, of course, how it can be applied and why he was using these many methods and wherever these were applicable. Yes, we have to find it out that also. So my point is that here the contribution of Mahavira, yes, as in many other areas. I'm just focusing only on one point, this binomial expansion is or should attribute to Mahavira. That's what. Well before, otherwise never. If you can look at the documents, it generally attributes to Omar Khayyam and Blaise Pascal. But it is not the fact. Mahavira has clearly gave the the practical way how it can be done. That's what my humble my presentation or I like to highlight that point only. Okay, yes, in the elaborate paper, it's a lot of things can be talked about because it's a vast topic or the text Mahavira Ganitha Sara Sangraha. Everything it is covering almost all the parts of or the areas of mathematics. That's why we can't do it in 1 hour or 1 day also. Right. Next. So these are all the reference which I took, and I would like to highlight here the last name, V.B. Panikar, Dr. V.B. Panikar. He was a retired engineering college professor in Kerala, and he does a lot of research and learning and interpretations of ancient mathematical texts, and he done actually a Malayalam translation of Ganitha Sara Sangraha. I was also associated while I was helping him to correct it or read it. Okay, I'll just read. Correct means in the sense, okay, just read, proofreading. I got inspired and I got all the insights. And when we were discussing it, we got all those insights. Okay, but he couldn't publish it because of he's trying to find a publisher. That's what he couldn't publish that book. It is still in the manuscript size only. Okay, yeah, next please. So here I would like to thank all of you, all the organizations for this wonderful opportunity and wonderful gathering and learning. Actually, this is a learning session for me, and definitely it will be helping all of us, those who are trying to learn the ancient mathematics. Thank you all. Thank you once again for this opportunity.
Sulek Saab.
I think Dr. Agrawal is on mute, so he needs to unmute you.
Unmute yourself, Sulek Saab.
Dr. Agrawal.
Dr. Agrawal, unmute yourself, please. You muted. Now you are okay.
Okay. So, thank you very much, Dr. Devraj, for your very interesting information about the methods of finding the cubes of certain quantities. Now, I invite the questions from the audience. Any question, please?
Hello. Hello.
Yes. Dr. Surendra ji.
Yes. Can I ask Devraj?
Yeah.
That does he have any comparison between what was known in Jain literature and what he's saying about the cubes?
Yeah, Dr. Devraj, please. Here is a question for you.
Jain literature, sir. This I'm taking from Mahavira Ganitha Sara Sangraha, how the Mahavira has explained the cubing methods. That's what I was discussing. So Mahavira has given these much different steps. In that we can find that, okay, the cubical expansion of binomials, that method. So that method is generally attributed to other people generally. So wherein I would like to attribute that method to Mahaviracharya.
What makes you say that? How do you know the references? What are the other references which were after that or before that? How do you know that?
After that, we can say, okay, different methods are there.
Yes.
But the first, yeah, in ancient Indian text also we can say. After that we can see, but before that I couldn't find out anything in Indian text.
Yeah, I will call you on the phone. I have your number 9847205803. We can talk.
Right,
about
right.
it. I don't waste your time now. Anyway,
okay.
Thank you.
Thank you, sir.
Yeah.
Thank you.
Any other question, please, from the audience? Okay. If there is no more question, let us thank Dr. Devraj once again for his interesting talk. Our next speaker is Dr. S.K. Uma. Dr. Uma is professor and head in the Department of Mathematics, Sir M. Visvesvaraya Institute of Technology, Bangalore in India. As you can see now, she will be speaking on indeterminate equations of first order and the second order and solutions by Mahaviracharya in comparison with other Indian mathematicians. So I request Dr. Uma to present her paper. By the way, there are 3 other authors in the paper which we cannot see on the slides. Padmaja Venugopal, Dr. K. Rupa, and Dr. S. Balchandra Rao. So I request Dr. Uma to present her work.
Hello, good evening, everyone. Namaste. I'm presenting on indeterminate equations of first order and second order. They are called as Kuttaka and Varga Prakriti in Sanskrit respectively. Solution given by Indian mathematicians and Mahaviracharya are discussed here. Next slide, please. There is a doc here. I'm not able to see the complete slide. Please check into that.
Should I share?
Yeah, the one part is blocked. I'm not able to see the complete slide.
Who is sharing? Is
that it's coming in the middle.
Yeah, it's okay.
Yeah, now it is fine. Now it is fine.
Okay.
Again, the black line. Yes, go on.
Yeah, it's okay now.
Yeah, okay now. Thank you. So mathematics is given supreme importance by Indian mathematicians, starting from Vedic lore. We have a shloka from Vedanga Jyotisha, which gives the importance and high priority given by the Indians to the mathematics. Yatha shikha mayuranam naganam manayo yatha tadvad Vedanga shastreshu ganitam murdanish sthitham. Which the meaning of this shloka is like the crest on the head of the peacock, like the gems in the hoods of the cobra, mathematics is at the top of Vedanga Shastras. So this is the supreme priority given by the Indians to the mathematics, and equation of the form ax plus by minus is equal to c, where abc are given integers, have infinitely many solutions. Such equation is called indeterminate equations. In fact, so we can say that the India's significant contribution to the field of mathematics is the solution of these kind of indeterminate equations. So they have given a very systematic way of systematic procedure for solving these kind of indeterminate equations. We can trace this equation from the Sulba Sutras itself, from the Vedic lore, which were Indian mathematical texts written between 800 BC and 500 BC. Baudhayana found two sets of positive integral solutions to set of simultaneous Diophantine equation, because these equations are nowadays called as Diophantine equations, and also attempted to solve simultaneous Diophantine equation up to 4 unknowns. Even in Apastambha, attempted simultaneous Diophantine equations with up to 5 unknowns. And the search goes like that, and the credit of giving a systematic procedure for solving indeterminate equation goes to Arabita 1, and further work was carried by different mathematicians like Brahmagupta, Bhaskara 1 and 2, Aryabhatta 2, Mahavira, and many other mathematicians and astronomers. Next slide, please. Next, please. Now, if you go to the Vedic lore, certain brick constructions, for example, if you take up the Garhyapatyagni altar, the construction description is given here, and that will lead to an indeterminate equation, simultaneous equation of the form x plus y equals 21, and x by p square plus y by q square is equal to 1. And here, having precisely two set of positive integral solutions, x, y, p, q, they are given 16, 5, 6, 3, and 9, 12, 6, 4. So this has been discussed there. And more difficult Diophantine problems arise from construction of another kind of sacrificial altar known as a Senachit. It's a falcon-shaped fire altar. Two such examples are given in Baudhayana and Apastambha. One equation with 4 unknowns and another equation with 5 unknowns. So it is shown here. In fact, actual difficulty is again in the construction, because the bricks have to be arranged in such a way as to have the prescribed shape of the falcon altar. And also, Sulba Sutras give several examples of Pythagorean triplets satisfying the equations x square plus y square is equal to z square. Katyayana has given a general rule for finding the solution of this equation. And in view of this abundant numerical examples and also Katyayana's rule, it seems that the Vedic mathematicians were aware of such a general formula. Next slide, please. Next, please. Now let us come to the method of solving indeterminate equations, and this method is known as Kuttaka method. The Kuttaka is the word used for the first order indeterminate equation, and the method of solving such equation is also called as Kuttaka method. And this Kuttaka is a special kind of division or distribution, and the process is explained here. If you take the form ax plus by, plus is not very prominently seen here. Anyway, ax plus by is equal to c. This kind of equation is solved by the Kuttaka method. And Bhaskara 1 deals with the method of solving indeterminate equations in the first chapter, Shlokas 41 to 52 of his Mahabhaskariyam. And all the problems of Kuttaka type are reduced to a standard form of ax plus or minus c by b is equal to y, where in this case A is called Bhajya, B is called Hara, C is called Kshepa or Shesha, according as upper sign plus or the lower sign minus is taken. The unknown x and y are called Gunakara and Labdha, which are to be determined by solving the equation. And the method is simple. The first Bhajya and Hara must be made relatively prime. This is achieved by finding their GCM or HCF. Method of finding GCM, HCF is known to even high school mathematical students. And the two Hara are both divided by the HCF to get the Dhrida, which is called a further irreducible Bhajya and Hara. With reference to these, the Kshepa or Kshesha has to be calculated. So simply have given the outline of the method, and I can explain this method with one example, which becomes very simple to understand. Next slide, please. Next. Thank you. One example is given here. The solution of the equation 100x plus 90 is equal to 63y. So if you compare with the standard form, here A is equal to 100, B is 63, C is equal to 90. And see, we go on dividing like this. A is here less than B. So we divide B by A. So when you divide 100 by 63, the quotient is 1 and the remainder is 37. Again, from this remainder 37, we divide the 63, quotient is 1 and the remainder is 26. Like that we go on till we get 1, that is shown here. And after doing this, we construct this table where, see, we take all these, the quotients 1, 1, 1, 2, 2, 2, 1 here, and then at the end, the Shesha or Kshepaka, and that is equal to 90 in this problem. So you multiply 90 by 1 and add to the 0. In the beginning, we consider it as 0 as Kshepaka. And then, so 90 into 2 plus 90 will give you 270. 270 into 2 plus 90 is 360. Like that we go on. 360 into 1 plus 270 is 900. Like that we go at the end till we complete the process. And finally, we are getting 2430 and 1530. These are the two values. We take x is equal to 1530 and y is equal to 2430. And we can see here from the equation, the coefficient of x is 100 and coefficient of y is 63. So here we have taken x as 1530. We divide this value by the coefficient of y. Similarly, the value for y is 2430. We divide this by the coefficient of x. And finally, we are getting an expression of the form 2430 is equal to 100 times 100 into 24 plus 30, and 1530 is equal to 63 into 24 plus 18. If you write the general, if the general solution is required, then we write the equation in the form x is equal to 63t plus 18, y is equal to 100t plus 30, where t is the parameter, and we give the integer values for c starting from 0, 0, 1, 2, 3, etc. So by giving those values, we can generate infinitely many solutions in integers. That is very, very important to note. So we get the solution like this. For t equals 0, 1830 is the set of solution. When t is equal to 1, we get 81, 130. Like that it goes on. So we can generate infinitely many solutions. So this is the general procedure I have explained. And this the rule for solving the indeterminate equation is differently given by different mathematicians and astronomers. Bhaskara 1 and later Brahmagupta and then Mahavira also. Next, please. Okay, now come to when we come to Aryabhatta, he takes the credit of giving a systematic method of proving the procedure for solving indeterminate equation. He explains the method in 2 stanzas, verses 32 and 33, and his method has been elaborated and explained with examples by his the next astronomer, Bhaskara 1. His algorithm is also given here. Please go to the next slide. I can explain the example given by Aryabhatta 1. Yeah, so these are 2 examples I have taken, which is given by Aryabhatta 1. He just gives this: find the number which gives 5 as the remainder when divided by 8, 4 as the remainder when divided by 9, and 1 as the remainder when divided by 7. And this, when we express in mathematical form, algebraically, takes the form n equals 8x plus 5 is equal to 9y plus 4 is equal to 7z plus 1. So if you take n as 85, this satisfies the given requirement. So one more problem is given similarly. Find the number n which leaves the remainder 1 when divided by 2, 3, 4, 5 and 6, but it is exactly divisible by 7, and this is satisfied by taking n is equal to 721. And here it is important to note that this problem, which has been given by Bhaskara, has been treated by Ibn al-Haytham in 1000 AD and Leonardo Fibonacci in 12,002 AD, and also by other mathematicians of 17th century, which was already discussed, and solution is given by Aryabhatta in 5th century itself. Please go to next slide. Now, when we come to Bhaskara, as it is mentioned already, Bhaskara has explained the Aryabhatta, and he is an exponent of the Aryabhattan school, and he has explained the Aryabhatta's method elaborately in his commentary. And he has given the method to solve an equation of the form ax plus or minus b is equal to ax plus or minus by is equal to c. It's not clearly seen here. Anyway, the later mathematicians like Brahmagupta and Mahavira, they have adopted the technique of Aryabhatta for solving indeterminate equations, and they have given their rule in a slightly different way that has been given in the paper. It has been explained in the paper. And Bhaskara, in fact, classifies the Kuttaka into 2 categories. He says Sagra Kuttakara, one with the residue, Agra stands for that residue, and Niragra Kuttakara without residue. Examples are given here with one example which corresponds to the equation n is equal to 5x plus 1 is equal to 7y plus 2, where the problem connected to this is find the number in which leaves 1 as the remainder when divided by 5 and 2 when divided by 7. When we go to the next example, so this is to the Niragra Kuttakara. The equation corresponding to this problem is 8x plus 6 is equal to 3y, and he mentions in the problem that say it is completely divisible by the number 13. And one more thing we have to note here, Bhaskara 1 applies this Kuttaka method for solving astronomical problems, which leads to indeterminate equations. So few examples are given in the next slide. I will just read one problem and I'll go to the next slide. Next, please. Next, please. Yeah. The font is very small. I'm not able to read properly. Anyway, I just read one problem. The residue of revolution of Saturn is 24. Find the Ahargana and the revolution performed by the Saturn. This is the problem in astronomy. Ahargana here means the number of elapsed days, civil days from the chosen epoch. And this leads to the indeterminate equation given here, 36 for taking the revolution, number of revolutions of Saturn into account. So this has been explained here. And the solution is also given. Ahargana is obtained x is equal to 3466888814. There are many digits in this number, and the revolution is also taken, and it is found out as y is equal to 32202. And a similar such problem is explained here with much more difficulty. That has led to the equation which is shown here. So I am not going to details. So this has been explained in the paper also. Next, please. Next, please. Another important thing here is solution. Hello? Solution of second order equation. So far what we have gone through is the solution of first order indeterminate equation, Kuttaka method. And here this second order equation is called as Varga Prakriti. And the credit of solving the second order equation, indeterminate equation, goes to Brahmagupta, and systematizing the procedure goes to Bhaskara too later. And see the very famous equation we have, all of us know, nx square plus 1 is equal to y square. This is second order indeterminate equation, which is called as Pell's equation because this has been solved by Brahmagupta 500-600 years earlier than the Euler and Lagrange. So this is wrongly called as Pell's equation. And see, Brahmagupta explains those lemmas and procedures are not given here. It has been presented in the paper. So Brahmagupta explains a method called Bhavana to solve second order indeterminate equations. And not only finding the solution, one set of solution, it is very, very interesting to note that he gives a method for generating a solution in integers. So the point is to be stressed here is finding the integer solution for these kind of equations is really difficult. And that has been successfully done by our Indian mathematicians. So Brahmagupta's method, Bhavana method, requires a trial solution. This is not a serious hiccup, but even small thing is also got over by Bhaskara too in his Chakravala method, which is really to be appreciated. And he gives a method for solving the second order equation, and particularly the famous equation 61x square plus 1 is equal to y square. This has got the solution, integer solution. The least integral value of x and y has got now 9 and 10 digits, which is shown here. And there is an interesting story behind this equation. This equation, which is called as Pell's equation now, this problem has been given as a challenge by Fermat to European mathematicians. A few of them accepted the challenge, and Bruker Valley found a solution known as Bruker value solution, but they came out with only rational solution. That means they were not able to find out integer solution. And they were struggling a lot. Later in 1632, Euler gave solution, the algorithm for finding the integer solution, and later Lagrange in 1767. And it is to be noted here, successfully Indians were able to solve this with a very precise algorithm, and they can generate even infinitely many integer solutions for these kind of problems. Next, please.
Yeah, Dr. Oma, you sum up in a minute time now.
Yeah, okay, sir. Then when you come to the Mahavira's contribution, and Mahavira is a celebrated Jain mathematician, and his treatise is Ganitasara Sangraha, which is a very, very important mathematical text, and which had become a textbook for a long time in South India. And there are many works on Mahavira's Ganitasara Sangraha. We have English translation by Professor Rangacharya, Telugu translation by Povaluri Mallanna, Hindi by L.C. Jain, and Kannada translation by Dr. Padmavatamma. And a large number of manuscripts are also available in Kerala, as mentioned by the previous speaker. And these all these facts show that how popular the Mahavira's mathematical work. And also it is to be noted that previously I mentioned Aryabhatta, Brahmagupta, Bhaskara. They are all mathematicians and astronomers. And his work is only purely a mathematical work. And Mahavira deals with different types of indeterminate equations. Next, please. And the very special thing to be noted here is we use different terms like Kuttaka, Kutta, Kuttakara, etc. for the method of solving equations. And Mahavira has a special preferential liking for calling it as Kuttikara. Kuttikara is the word used by Mahavira in his text. And he gives the method for finding solution of first order equation, which is taken in the form of ax plus c divided by b is equal to y. And he has given many interesting problems. And he deals with the simultaneous equations also. That is to be noted, which is very, very important. There is a reference for simultaneous equation, which is in the form of by1 is equal to a1x plus or minus c1, etc., which is shown here. And See, this is called as a sums-list Kuttaka in technical terms. And Aryabhatta too in 1950 has dealt with these kind of equations. But prior to him, next slide please. Prior to him, Mahavira has taken up this. This is with a variable.
Please sum up. Please sum up now.
Yeah, okay. So, and he has dealt with many examples also given. Very beautifully, it is explained with the poetic imagination and artistic creativity with the mathematical intellectual. And see, giving different values for B, he has given a method for solving simultaneous equations. Later, his method has been taken by and developed by other mathematicians. Next, please. Next, please. Next slide. Yeah, to conclude, see, I have present, and even Mahavira has dealt with quadratic indeterminate equations, single indeterminate equation with more unknowns and higher order equation higher than the second. So all has been given in Ganita Sara Sangraha. And here I think I have highlighted the contribution of Indian mathematicians in solving the indeterminate equations, and celebrated Jain mathematician Mahavira's Ganita Sara Sangraha is a beautiful mathematical text, and he has incorporated his own significant contribution in the text in a natural way. And another very important thing is it is an independent text and not a part of the astronomical text. Thank you very much. I thank the organizer for giving me this wonderful opportunity to present before you. Thank you once again.
Okay, we can have one or two questions, please, from the audience.
There is a question in Q&A. What language did Mahavira Acharya write his
in Sanskrit? Sanskrit. I have given some verses in the paper, which I could not show here. It is in Sanskrit.
Thank you.
But the question is Mahavira Acharya's, his native language, mother tongue, is it Kannada or Dravid?
Kannada, because he is in the court of Rashtrakuta king in 9th century. That time it is Kannada.
I see. Oh, thank you.
Old, we call it as Hale Kannada, old style of Kannada.
It's Hale Kannada.
Yeah, Hale Kannada. Yes, yes.
It's basically Dr. old Kannada.
Correct.
Translates.
There is a small question from me.
Yes.
Have you compared all these methods? Because it is interesting to know that which method is faster, which is better. So have you made a comparison?
The first order equation methods are more or less similar given by all mathematicians. But when you come to the second order, that Chakravala method of Bhaskara too is will involve less number of steps compared to the modern method given by Lagrange or Euler.
So have you analyzed why this modern method has more steps? Why these Lagrange and Euler, they have not adopted that method which is shorter? Why?
That comparison is to be given.
That is actually the main part. We have to compare. We have to give reason for that. Anyway, thank you very much for a very interesting talk. And if anybody is interested, can discuss later on phone or otherwise. Thank you. Our next speaker, Dr. N. Shivkumar. Now, Dr. N. Shivkumar is professor in the Department of Mathematics, RV College of Engineering, Bangalore. Now, in this paper, there is another name also. Yeah, it is given here. Dr. B. Sudarshan. As you can see, he is undergraduate student. It is good that some undergraduate student is also associated with some research paper. The topic you can see here, almost similar it seems, because Dr. N. Shivkumar is also dealing with Cuticle equations, and Dr. Uma also dealt little bit from that. Anyway, I request Dr. Shivkumar to present his work. Shivkumar, please.
Hello everyone. Am I audible?
Yes.
Yes, Yes.
I am Dr. N. Shivkumar, professor and former HOD of Department of Mathematics, RV College of Engineering, Bangalore. Sudarshan is a joint author and senior student working under me who has a great passion for mathematics. In this PPT, we will be explaining the methods given by Mahans. We will also be addressing Arabita's approach for solving Cuticle equation. At the end of the presentation, we will be providing a comparison between the two methods given by Mahavira and Arabita using Python software, and the simulation results have also been shown in the future slides. This topic needs a lot of equation representations and workings to be shown for clear understanding, but due to time constraint, we will be explaining only the procedure of the methods, but the detailed working and illustrations examples are provided in the detailed and elaborate paper. Next slide, please. Next slide, please. Say the words Kuttaka, Kuttakara, and Kutikara all means the same. Mahaviracharya has preferentially named it Kutikara. We will discuss the first method now for a general equation.
So next slide, please, sir.
Now, this one let it be there. Mahavira wrote an extensive Sanskrit treatise called Ganitasara Sangraha during about 850 CE. Mahaviracharya in his Ganitasara Sangraha has discussed the analysis of indeterminate equations of the first order. The analysis of linear indeterminate equations have been discussed under 5 methods. Now, the 5 methods I am going to list now: Vallika Kutakara, Kutikara, Vishama Kutikara, Sakala Kutikara, Suvarna Kutikara, Vichitra Kutikara. Linear Diophantine equations were called as Kutika in the past eras. They received special importance by many authors of mathematics and astronomy. There are few terminologies involved here. Suppose if you consider the equation y 13y equal to 8x plus 6, y will be 8x plus 6 by 13. 8 is called as a dividend and 6 is mati and 13 is the divisor. Next slide, please. Next slide.
Yeah, it is here.
Now I'll be discussing the first method, Vallika Kutikara. There are basically 4 major steps involved in the procedure to find the solution under this method. The first step is to find the quotient by dividing the dividend by the divisor. The second step is write down the quotient chain. The third step is to find the group value of the obtained chain. Here we will discuss for a general equation, pictorial representation has been shown here. Next slide, please. Next slide.
Yeah, due to bandwidth issue, you will have a lag after me pressing my next slide. You should see now.
Okay. Now, observations and solutions. The solution set obtained is the lowest possible values of xy. With the help of these values, we can obtain solutions of higher value. Let the solution set of the equation obtained be x naught, y naught. Then the higher value solutions of the same equations is given by xn plus 1 is xn plus alpha n, yn plus 1 is yn plus beta n, where alpha is the coefficient of y or the divisor, beta is the coefficient of x or the dividend, and n equal to 0, 1, 2, 3. Close observation into the quotient chain, we can observe that the group number is also a solution for x for the given equation, and the value below, the group value is the solution of y correspondingly. Interestingly, if the values are written down as a sequence, they form an arithmetic progression with a common difference alpha or beta respectively. Next slide. Next slide, please. Other than the previous method shown in the previous slide, we have also found out another way of finding higher valued solutions, and it is given by the formula x naught times lambda plus 1 to the power n minus 1, where lambda is the divisor of the problem and n equal to 1, 2, 3. Interestingly, if these solutions are written down as a sequence, they form a geometric progression with common ratio equal to lambda plus 1. Next slide, please. Next slide. Up till now, we have discussed for solving single linear indeterminate equation. Before we proceed to the next method, the following is to be noted. Vishama and Sakala Kuttikara methods deal with solving simultaneous linear indeterminate equations. Next slide. Next slide, please. Now, introduction to Sakala Kuttikara. We arrive at fractional values as the solutions for the equations when we applied the Vishama rule of distribution. Therefore, this had to be corrected, modified such that the method would yield whole number solutions. Also, whenever the value of x was substituted, it yielded the same y when the Vishama method of distribution was used. Whenever the value of the Mati was huge, usage of the Vallika Kuttikara method became very tedious and a laborious process. These reasons were vital for the creation of a new and better method. Therefore, the Sakala Kuttikara method came into existence to solve equations of the previous types, which yielded whole numbers values of x and also different values of y when substituted. Incidentally, Sakala in Kannada word which means everything. Next slide. During the formation of the quotient chain, the Mati value given in the question is divided by the divisor and the remainder so obtained will be the new Mati value, and the optionally chosen number will be added to this new value. The rest of the procedure is the same as in the first method. The length of the quotient chain is to be noted. If the length of the chain is an odd number, then the remainder obtained by dividing the group value by the divisor will correspond to the solution of positive Mati. If the length of the chain is an even number, then the remainder obtained by dividing the group value by the divisor will correspond to the solution of negative Mati. Next slide, please. Here, another method, namely Suvarna Kuttikara. The Kuttika essentially referred to calculations involving gold of various purities to find the purity of a mixture and so on. There is no general rule for this Kuttaka, but this has a collection of rules. This bifurcation may have been done in order to ease the readers. This work as a textbook for reference during those times in understanding the mathematical concepts involved, also the practical usage of the concepts, since making mixed gold, finding the weight of gold present in specific varna are all required components to be known during the foregoing process. A few rules are given just to get a glimpse of this Kuttaka. Next slide. Next slide, please. Vichitra Kuttikara. The word Vichitra is essentially a Kannada word which means out of the ordinary or not normal in layman's sense. This Kuttikara essentially gives many miscellaneous problems and its calculation. Some of them are combinatorics, truthful and untruthful statements, arrangement of arrows, problems involving money, capital, and so on. Just as the previous method, there is no specific or general rule for this method of Kuttaka. It is a combination of many rules and regulations for the respective events, instances, similar to the way how Suvarna Kuttikara was explained. Next slide. Here, Arabita's approach towards the Kuttaka, Arabita's problem was to find a number capital N such that when n was divided by two divisors a comma b yielded reminders r1, r2. Here two cases has been discussed, r1 greater than r2 and r1 less than r2. When r1 greater than r2, capital N will be ax plus r1 minus r2 equal to by, and here y equal to ax plus c by b. When r1 less than r2, our x becomes by plus c upon a. Next slide. Next slide. In this, I have shown the second case, namely r1 less than r2. In this, we are going to get x as by plus c plus by upon a. Next slide. Next slide, please. In terminology of the, see, for comparing the two methods given by Mahavira and Arabita, we define two parameters namely method complexity and efficiency of algorithm. In terminology of the equation, Mahaviracharya has used the word mati or agra, whereas Arabita has used the word interior number. Therefore, I showed here Mahaviracharya, we have taken the core method. In this, one table shows us y equal to 8x plus 6 by 13. Here 6 is mati, and in Arabita's table y equal to same 8x plus 6 by 13, and 6 is the interior number. Next slide, please. Here, the first point is same as per the Mahaviracharya. The first quotient obtained during mutual division of the two numbers is always neglected and is not considered for formation of quotient chain. Also, a least remainder should always exist at the end of the division process. Number of divisions made should be of odd order. In Arabita's method, all quotients are considered for the formation of quotient chain. A remainder may or may not exist. Number of divisions made is immaterial here. Next slide, please. Next slide. Yes. We have found many differences and we have shown in the PPT, but for time being, I will explain only the major points. Considering Mahaviracharya, length of the quotient chain does not matter. Considering Aryabhata, length of the quotient chain is required for calculation. While choosing the optionally chosen number, there are few rules to be followed. Incidentally, both these rules are same for Aryabhata. Now, considering Mahaviracharya, if the sign of mati is positive, then the value will always be 1. If the sign of the mati is negative, then the value will always be mati plus 1. Unlike the other method in Aryabhata, as per Aryabhata, both the values of x and y can be found from the quotient chain values. The remainder obtained from dividing the group value of the chain by the dividend of the problem yields value of y. The remainder obtained from dividing the group value of the chain by the divisor of the problem yields the value of x. Next slide. Next slide, please. Now, here we will test the efficiency of the algorithm to return the answer. The time taken by the program will also be noted. This will provide proof for us. The Mahavira's procedure for Kuttaka is more efficient than Aryabhata. And we have actually taken y is 63x plus 7 by 23. And in problem 2, we have taken y is 5x plus 2 upon 9. Next slide. Next slide, please. Next slide. We are showing the simulation screenshots of the methods given by Mahavira Charya and Arabita simulated using Python here. Next slide. Next slide, please. By this, we are showing that the methods given by Mahavira Charya were better efficient than Arabita, but it is to be noted that this is our view of the methods. With this, the presentation is over. Other details and illustrative elaborate examples for each method given in the PPT have been discussed in the very detailed paper. I and my student Sudarshan wish to thank the organizer for providing us the platform for showing our findings. Thank you.
Any question, please? We have time.
Hello, sir. Hello, sir.
Hello.
With the permission of Dr. Shivkumar and all the panelists, I wish to make a few points at the end. Hello.
You're audible, but you are cracking up. You can speak.
Pardon me, sir.
You're cracking up a little bit.
No question from the audience. If that is so, let us thank Dr. Shivkumar.
Yes.
For interesting talk and about Kuttaka equations.
Dr. Agrawal.
Yes,
Dr. Agrawal, maybe we can take 5-minute break and then come back and start with the next talk. We have time, so let's do that. I'm sure people are.
Before that, Sudarshan, the student, want to say a few words actually.
Yeah. 5-minute break, please.
Yeah, presentation is Dr. Shivkumar over.
Yeah.
If
Dr. Agrawal, sorry to interrupt. So the Mr. Sudarshan Balaji would like to say a few words. He was the co-author for the presentation.
Okay. Yeah. Take a minute.
Yes, sir. Just 1 minute, sir. I will finish my.
Okay.
The thing is, sir, when we were doing our research in these methods of Mahavira Charya, this Sakala Kuttaka is actually the most prominent methods of all the methods given for the Kuttaka methods, because usually what people do is they use this Kuttaka methods for the field of astronomy, and they use a particular method called as concept of constant pulverizer, which they iterate over and over and find values for the same divisor and dividend, but different values of the mati, as sir had explained. In this Sakala Kuttikara, which Mahavira Charya had given, this analogously had used this concept of constant pulverizer, and this in fact can solve almost all types of linear indeterminate equations. So among all the 5 methods given by Mahavira Charya, I can say that Sakala Kuttaka is the most prominent of all the 5 methods, and that this method also uses the concept of constant pulverizer, which is seen in astronomy and which is used in astronomy. Basically, even though we did not find astronomical examples given in the Kuttaka chapter given by Mahavira Charya, still this method utilizes the concept which is to be used in astronomy, and he has also provided a beautiful method for solving such equations as well. In fact, if this method is used for problems given in astronomy, this gives a better result than the other methods which we have come across. That's what I wanted to point out at the end. Thank you for your time.
Thank you, Dr. Shivkumar and
Thank you.
Dr. Sudarshan for interesting talk. Thank you very much.
Yes, sir. Thank you, sir.
So, as Sulekh has said, that we have 5 minutes or 10 minutes?
Take 10 minutes, 10 minutes. I saw this.
10 minutes. Okay.
For everybody, I have one on the chat box. Our Praveen K. Shah, who has been leading the effort in Jain Pathshala for the last 35 years. He just sent a message. He has been running what we call Jaina e-library, where we have thousands and thousands of books and many millions pages of Jain Agams and others. And he says, if you are looking, for all of us, if you're looking any material for your work and research and you cannot find it, please send me the details in email at Jaina e-library and he can find it. He will let you know. All of that material is now electronically available. So you can contact me or we will contact Praveen Kesha. Thank you. Let's take 10-minute break. Come back. This is 10:10. Then we will come back in 11.
In India, it is 9:20.
I know. That's a.
So we come back at 9:30.
10 minutes.
10 minutes. Thank you. Thank you. That's good.
Get you a cup of coffee or tea or go to the restroom.
Yeah, we need that.
Yes. Me too. Thank you. See you.
Thank you.
Ample video.
So for now, I have muted everybody. So if you would wish to speak, please don't forget to unmute.
Dr. Agrawal, welcome. Dr. Agrawal ji, welcome back. Welcome back. We can start the session now. You are muted.
You have to unmute yourself, Dr.
Yeah, you have to unmute.
Yes.
Okay.
Yeah, now it is fine. Thank you. Hope you had a good break for 10 minutes.
Yeah, we needed that.
Yeah, please, yes. Me too.
So, Salikji, we start now?
Yes, please. Yes.
Yeah. So, our can everybody hear me?
Yes.
Particularly, Dr. Rupa, can you hear me?
Yes, sir, I can hear you.
Yeah. So, our next speaker is Dr. Rupa. She is a professor and coordinator, Department of Mathematics, Global Academy of Technology in Bangalore. Again, there are 3 co-authors in the paper, Dr. S.K. Uma, Dr. Padmaja Venugopal, and Dr. L. Balchandra Rao. Now, the topic of the talk is Geometry in Mahavira Acharya's Gadit Sar Sangrah, a comparison with other Indian contributions. So, Dr. Rupa, you can please start the talk.
Thank you, sir, for a kind introduction. Namaste, everyone. Sir, myself, Dr. Uma and Dr. Padmaja, we are working on classical Indian astronomy under the guidance of Dr. S. Balchandra Rao, sir. So today I will be presenting on or highlighting on geometry in Mahaviracharya's Ganita Sara Sangraha and compare it with other Indian works. Next slide, please. The subject of mathematics, as we all know, has got high importance since Vedic times. The constructions of altars required the knowledge of the properties of a square, a rectangle, rhombus, square, trapezium, etc. Hence, geometry was developed. We find very significant contributions of the Jainas in the development of geometry. Mahaviracharya was a precious gem among all the mathematicians. His work, Ganita Sara Sangraha, is the earliest Indian text entirely devoted to mathematics. Mahavira stresses the importance of mathematics in shlokas 9 to 16 of chapter 1. The 7th chapter of Ganita Sara Sangraha is completely dedicated to geometry, called Kshetra Ganita Vyavahara. In his work, Kshetra means a plane figure. Brahmagupta, Sridhara, Bhaskara have devoted chapters as Kshetra Vyavahara in their works. But it has been observed that there is a considerable similarity in certain respect among the works of Brahmagupta, Mahavira and Bhaskara too. But Mahavira introduced modifications, improvements, or generalizations upon the works of his predecessors, particularly Brahmagupta. In the 7th chapter of Ganita Sara Sangraha, Mahavira enumerates 8 varieties of curvilinear figures. In addition to these, Mahavira was the first Indian mathematician to discuss Yavakara, Murajakara, Panavakara, Vajrakara, Ubhaya Nishiddha Kshetra, Eka Nishiddha Kshetra, the Hatadanta Kshetra, etc. In Indian geometry, one system of naming figures is according to the number of sides of the figures. The areas are taken to be of 2 kinds by Jainas in accordance to the nature of the result, namely that which is approximate for practical purposes and that which is minutely accurate. Mahavira also does the same. First, he gives approximate formulas and later minutely accurate formulae for finding the areas of figures. Next slide, please. Quadrilaterals. The classification of quadrilaterals according to the sides as well as angles are found as early as the Surya Pragnapti. Mahavira discusses 5 varieties of quadrilaterals in shlokas 54 to 59 of chapter 7. So he names them Sama Chaturashra, then Ayata Chaturashra, Trisama Chaturashra, Dvisama Chaturashra, and Vishama Chaturashra. So 5 types he discusses. In shloka 50, he gives the area of a quadrilateral as here, square root of s minus a into s minus b, s minus c into s minus d, where s is a plus b plus c plus d divided by 2, a, b, c, and d being the sides. The same formula is given by Brahmagupta, Sridhara, and Shripati, but none of them have explicitly mentioned it holds good for inscribed figure. It is Bhaskara too who has said the above formula gives only an approximate value of the area of quadrilaterals. But Mahavira notes the above formula is not applicable to Vishama Chaturashra, but it is applicable to only cyclic quadrilaterals. He is the only mathematician says it is applicable only to cyclic quadrilaterals. Next slide, please. Mahavira gives an ingenious method of obtaining a quadrilateral with sides in integer given its area in shloka number 152. So here I'm not going into the detail of that. He gives a very interesting and ingenious method of finding the sites given the area in integers. Next one, please. Circles. The most important curvilinear figure dealt by Jainas is circles, its areas and circumference. In Jaina cosmography, the earth is supposed to be a flat plane divided into successive regions of land and water by system of concentric circles. It is seen that in calculating area and circumference, C is equal to root 10 into D is used, and A is equal to root 10 into D by 2 whole square is used, as stated by Umaswati and Jinabhadra Ghani. Mahavira gives approximate area as 3 into D by 2 whole square and accurate area as root 10 into D divided by 2 whole square. As I mentioned earlier, there is a practice of giving approximate areas for practical purposes and then correcting them to give minutely accurate areas. Here we notice that the approximate value of pi is taken to be root 10. In the early canonical works of Jainas, pi was considered root 10, it was used by Umaswati. Varahamihira also used the same root 10, Brahmagupta and Sridhar also. Baudhayana gives pi is equal to, I think, 3.004. Aryabhatta gives a better value of pi as 62832 divided by 2 followed by 4 zeros, which is around 3.1416. Bhaskara gives approximate value of pi as 22 by 7, or I can say it is he mentions as 3927 divided by 1250, which is 3.1416. And Madhava gives pi correct up to 10 decimal places. Okay, next slide, please. Mahavira is the first to speak of a circle inscribed within a triangle and its diameter. In Shloka 223.5, he says the exact area of any figure other than a rectangle should be divided by 1/4 the perimeter to get the diameter of a circle inscribed within that figure. So the formula is like this: in diameter can be found using the area of triangle divided by 1/4 the circumference of the triangle. Next slide, please. Areas of some special curves. One of the very significant contribution of Mahavira is discussion of some special curves. Mahavira, Sridhara, Aryabhatta II, and Narayana Pandita, they have discussed the measurement of certain other plane figures such as the shape of a barley corn, Yavakara, then drum, Murajakara, elephant tusk, crescent moon, thunderbolt, etc. The formulas discussed in most of in these cases are only roughly approximate, and some of them are deduced easily from the results already obtained. These examples pertaining to this we have discussed in our paper. Mahavira says, while discussing calculation regarding to complex objects and figures, the gross calculation should be obtained by dividing the figure or object into similar objects or figures. So next slide, please. Area bounded by circles. Mahavira is supposed to be the first mathematician to have discussed the accurate formula for the area of space enclosed by 3 or more equal and mutually touching circles, and also minutely accurate area of the region enclosed by 4 circles touching each other. He says area A is equal to diameter square minus area of one circle, that is d square minus root 10 d square divided by 4. where the equilateral triangle is formed by the center of three circles. Each side of the triangle is equal to a diameter each of the circle of each of the circle. He gives for for area of enclosed between the three circles, A is equal to √3 divided by 4 d square minus 1 divided by 2 √10 into d square divided by 4. And one important thing we have to observe here is Mahavira generalizes this his analysis to get approximate area of the space enclosed by any number of circles, equal circles touching each other, as A is equal to S square divided by 3 into n minus 1 by n, where S is the semi-perimeter, and then the area enclosed by the semi-perimeter, I can say. And this is the generalization given by Mahavira only and not other mathematicians. But Narayana Pandita in his Ganita Kaumudi also gives the same formula. Maybe getting inspired by Mahavira's work, he also has given the same formula for finding the area inscribed between equal circles. Next slide, please. Elongated circle or Ayathavritta. Mahavira calls an elongated circle or an ellipse as Ayathavritta. Though the ellipse was known to Indians, we do not find any formulae for its mensuration in any of the works of mathematics except the Ganita Sara Sangraha. Mahavira gives a roughly approximate formula, though he gives a roughly approximate formula, but he is the first one to give the formula for the ellipse. And also he gives formula for finding the circumference of the ellipse. By my next speaker, Dr. Padmaja Venugopal, will be explaining in detail the formulas of Mahavira. Next slide, please. Conchiforms. Mahavira gives approximate area and perimeter of the conchiform figure. Perhaps the inspiration for Mahavira for discussing these shapes could be there were cross sections of three-dimensional containers to store water, oil, etc. So he gives formulas for these type of shapes. He says perimeter C is equal to √3 into d minus 1 by 2m, and area is equal to C divided by 2 whole square into 1 by 3 plus 3 by 4 m by 2 whole square. And later he corrects the formula. Here he uses corrects or gives minutely accurate formula in this form, where he uses √10 here. Earlier he used √3 for approximate formula, and then for getting the accurate answer he uses √10, and this is the formula here. I will not spell out that. The formula can be seen here, and circumference of the mouth of the conchiform figure is given as d minus m by 2 into √10. So as I told, Narayana Pandita, getting inspired by Mahavira's work, he gives almost the similar formulas in his work, but also he makes an addition to that, and he gives the converse of finding the diameter and phase given the area pertaining to this context of conchiform. Next one, please. Mahavira gives the rule for finding approximate and accurate volume of a sphere in Shloka 28.5 of chapter 8. So he says approximate volume of a sphere is half of the cube of radius multiplied by 9. This approximate volume multiplied by 9 and divided by 10, neglecting the remainder, gives the accurate volume. So here our approximate volume is 9 by 2 r cube, and accurate volume is 9 by 10 into 9 by 2 r cube. So, and Aryabhatta gives the same as pi d square by 4 into root of pi d square divided by 4. In Bhaskara's Leelavati, volume is taken or given as 4 pi r cube divided by 3. Bhaskara too, he seems to be inspired by the work of Mahavira. He improves upon the results, but he never acknowledges Mahavira in his work. Next slide, please. In India, Mahavira is the first mathematician to give the rule for finding area of curved surfaces of spherical segment. He's the first one to give this. The convex spherical sphere is compared to Katwala, that is pit or hole in the ground, and convex spherical segment to Kurmaniba, the back of a tortoise. Mahavira explains that 1/4 of the circumference multiplied by the diameter gives the calculated area. So that is A is equal to circumference by 4 into Vishkamba. That Vishkamba means extension or diameter in particular. So this formula we can also be interpret as A is equal to P by 4 into diameter.
Kumarji, is there any indication after 15 minutes?
Next.
Is there any indication after 15 minutes?
Sir,
I think there is no indication, it seems. Initially it was. So 15 minutes are over, you can sum it up in one.
Okay, sir. Mahavira discusses shapes like hexagon. He gives the formula for finding the perimeter and its area. He discusses rings. The measurement of the inline annular figure is to be obtained from the diameter as diminished by the annular area. So he says area of is equal to d plus or minus t into root 10 divided by t, root 10 into t, where d is the inner diameter and t is the width of the annulus. It might find an application in the study of annular solar eclipse in astronomy. So this formula was given by Mahavira. Next slide, please. So these are some of the references I have listed. And once again, I thank the organizers for giving me an opportunity to present my paper.
Thank you, Dr. Rupa.
Thank you, sir.
We can have 1 or 2 questions from the audience. Dr. Rupa is available. Any question, please?
So we have one online. It says, how does Mahavira Acharya is integrated in Jain mathematics?
Pardon me, sir. How is
This was
Mahavira
a
Acharya?
general question earlier asked by Dr. Kaskiwala. He's asking, how does Mahavira Acharya is integrated in Jain mathematics? How exactly is integrated in Jain mathematics? Anyone in the panel could answer, because most of them had Mahavira Acharya's working actually.
That is also my question.
I have just one comment that when you complete your paper, we like to see a comparison of your work with some of the Greek classic, like what Euclid wrote on elements, a similar class in Greeks.
Okay, sir.
Spherica, Arithmetica, Element, they have done very similar work. So
okay, sir.
Some similar comparison with other civilization. Thank you.
Oh, okay, sir. Actually, my presentation was comparison with the Indian contribution. So we will make a note of it, sir.
Thank you.
I think, Dr. Rupa, you might have received a white paper from Pankajji. That was about a sort of comparison with Euclid's element and other.
Yes, sir.
So that would have been a wonderful thing. But anyway, there is time, you can do that now.
Okay, sir. Okay, sir. Sure, sir.
So that question is unanswered. Surendraji, you were also asking the same question?
Yeah, same question.
How Mahavira Acharya was integrated in Jain mathematics? That was the question?
Yeah, and what time? At what time? What period?
What time?
At what period?
Okay, at what period? So anybody from the audience?
9th century.
Hey, Vicky says 9th century. I'm Googling
9th
it.
century, yes, sir.
9th century.
Mahavira
Yeah, 9th
Charya.
century.
Mahavira Charya is a Jain scholar, and he's patronized by the Rashtrakoot dynasty, Amogha Varsha Napratung, during the period of 814 to 877. And whenever Jain Acharyas feels that the readers feeling difficulty to understand the classical canonical text like Jambudip Pragyapti, like Teloy Parnati, like Dhavala, because a lot of mathematics involved in the discussion, philosophical discussion. Therefore, they have created purely mathematical text. The purpose of Mahavira Acharya to write the Ganit Sar Sangraha is to provide a textbook to the learned scholar who are interested to know more and explain the philosophical thoughts contained in the Jain literature. They are not intended to develop the mathematics. They are intended to train the readers to understand well the canonical text.
Yeah, we understand that. No, I think there's no doubt about that. I'm still not convinced the periods when we are trying to say that was done in Jain literature much earlier than what was known later. Secondly, I even checked that the volume which was giving accurate, which is not accurate. The accurate formula for the volume was not correct, according to what is correct. So anyway, we'll talk about that later on. I will in touch with her. I will be in touch with her.
Yeah.
Okay, let us thank Dr. Rupa for very interesting, excellent presentation. And we move to the next speaker. Our next speaker is Dr. Padmaja Venugopal. She is working as a professor and head Department of Mathematics, SIB Institute of Technology, Bangalore. And you have the slide. She is going to speak on Mahavira Acharya's expression for circumference of ellipse, a comparison with Sri Nivas Ramanujan and modern system. So, Dr. Padmaja, please. Dr. Padmaja, you can start your presentation.
Dr. Padmaja, we are not able to hear you.
You may have muted your headphones. Yeah, now we are okay. Can you talk?
Am I audible, sir?
Yes, now you are.
How you are?
Namaste. Shall I start my presentation, sir?
Yeah, you start, please.
Namaste. I thank the organizers for providing me an opportunity to make my presentation. I'll be making a brief note on Mahavira's expression for circumference of the ellipse, a comparison with Srinivasa Ramanujan and modern system. Mahavira was a celebrated astronomer who flourished in the court of Rashtrakuta king Amogha Varsha Nrupatunga. Next slide, please. He, in fact, was a very excellent mathematician, and implicitly he was an astronomer who contributed majorly to the field of astronomy by giving a wonderful expression for the circumference of the ellipse. which no astronomers of his period could think of. In fact, he was during the period 850 AD, he had composed his magnum opus, Ganitasara Sangraha, which has a pride of place, particularly in South India. He has occupied a pivotal place between his predecessors Aryabhata I, Bhaskara I, and Brahmagupta, and his successors Sridhara, Bhaskaracharya II, and Aryabhata II. In fact, Mahavira is supposed to have drawn inspiration from the Ganita texts such as Surya Prajnapti, Chandra Prajnapti, and Jambu Dvipa Prajnapti. The credit of giving the expression for NCR goes to Mahavira. He was in fact the first in the history of world mathematics to give the expression for NCR, and he had also given many examples related to that. We find in fact one idol in Somnathpura, that is idol of Nataraja, based on this problem, that is NCR. We also find some examples in the text like Sushruta Samhita, Chandra Sutra, and ancient Jain works. Next slide, please. Possibly Mahavira was the first mathematician in the ancient and medieval texts to speak about ellipse. He refers to the ellipse as Ayat Vritta. He was perhaps inspired by the discussions on Samachakravala, Vishamachakravala by ancient Jain mathematicians. He has in fact given the formula for ellipse, perimeter of ellipse, as under root 60 a squared plus 24b squared, where a and b are semi-major and semi-minor axis, and that reduces to 2 pi a into under root 1 minus 3 by 5 e squared, where e is the eccentricity of the ellipse of the planet under consideration, and this expression turns out to be remarkably close to the modern one. And the primary motivation to get an expression for perimeter of the ellipse in celestial mechanics is the desire to calculate the elliptical orbit of the planet. Now we can also give the perimeter of the ellipse in terms of combinations of arithmetic mean, geometric mean, and harmonic mean, and we have the formula here, that is P equals 5 divided by 8 times 21 a squared minus 2g minus 3h. Here AGH represent the arithmetic mean, geometric mean, and harmonic mean respectively. The next slide, please. Next slide.
Yeah.
Next slide, sir. Now, the great genius Ramanujan has in fact given the expression for the perimeter of the ellipse, and he has noted down in his notebook, which was not presented for long, which was not published for long, and these expressions were found in his notebook. Ellipse satisfies the equation x squared by a squared plus y squared by b squared is equal to 1 with the condition a not equal to b. If a equals b, this expression reduces to a circle centered at origin and radius a. Suppose if a is not equal to b, we find two possibilities. A can be either greater than b or it can be less than b. If a is greater than b, then the circle will be elongated horizontally, and if a is less than b, elongation is vertical. So that will approximate to an ellipse. The following expressions have been proposed over centuries, and the last one, that is P4, has been given by Srinivasa Ramanujan. I will not read out the expressions. Now this P1, P2, P3, P4, they are all discovered over centuries. P1 gives an error. These are all expressions for perimeter of the ellipse. P1 gives an error of about 30% when compared to the modern expression. P2 gives an error of 10%, P3 3%, and P4 0.3%. P4, as I had mentioned earlier, that is the expression given by Srinivasa Ramanujan. However, he was not satisfied with the 0.3% error. So he went on to improve upon the expression of the ellipse, and we find the second approximation, which we can locate on the screen. And there were some more further improvements for the perimeter of the ellipse. We all know that the perimeter of the ellipse cannot be exact because it ends up in a double integral, and the last one being given by Rakas, and this is in fact the expression used in today's computer programs. The next slide, please. I have gone for calculating the perimeter of the ellipse using different systems. That is Ramanujan's first approximation formula, second approximation formula, and the formula given by Mahavira, and the computer program, that is the last expression which I had talked about. Now the second column is A, that is semi-major axis, and the third column is B, semi-minor axis. I've gone for freezing A as 15 units, and I have varied B from 0 to 15 because of the restrictions of the slides here. Actually, I've gone for making 3 tables, and I am showing only 1 table here. Now B, I have varied from 0 to 15. Beginning, I have given step length of very small size, that is 0.05, 0.125. Then from 4 onwards, I've gone for varying at a step length of about 1 unit. Now I have gone for listing the values of the perimeter we have obtained using Ramanujan's first approximation formula, Mahavira's expression for ellipse, perimeter of the ellipse, Ramanujan's second approximation formula, and the last one is being the modern formula. And if we look at the graph may be not very clear. If I'm permitted to go for a separate slide for this graph, I think it would have been better for us to make a comparison. So if we observe the graph, we find that the values given by Mahavira coincide very well with those of the other 3 systems, and also at the end, in between, we find a small deviation in the values. This proves that Mahavira formula is an excellent one, which is very much comparable to the modern value. Next slide, please. Now coming to Mandapala, the equation of center. As I had pointed out earlier, this desire for calculation of the perimeter of the ellipse is to find the elliptical orbit. This equation of center is an important correction or the equation that has to be considered for adding it to the mean position of the planet. Supposing if you consider sun or the moon, we call those as heavenly bodies. In Indian system as well as in modern system, we assume that the mean planet takes a circular orbit, whereas all Indians, even the Western astronomers, were aware that the planets or the heavenly bodies were not moving in a circular orbit, but so they postulated a theory which is referred to as epicyclic theory. Next slide, please. Now, this epicyclic theory is that is peripheries. Here we take different for different heavenly bodies. Now, periphery at any point P. I'll come to the next slide. I'll show you the figure there. Now, we can look at the expression for the periphery at any point P. Here, PE represents periphery at the end of the even quadrant. P0 represents the periphery at the end of odd quadrant. M is the angular distance between the mean planet and the planet's apogee. Now, in ancient system, traditional system, even in Western system, that is before 18th century or 17th century, there was a practice to consider the apogee. Apogee is the farthest point of the heavenly body from the earth. Because we are observers from the earth, we have 2 points, that is nearest point and farthest point from the earth. So farthest point is referred to as apogee, the nearest one is referred to as perigee. And now M is the angular difference or angular distance between the sun and the apogee. Now, next slide, please. This is the epicyclic theory, that is epicyclic theory I was talking about. Now the mean planet is supposed to move around a bigger circle, and the actual planet, true planet, takes a smaller circle centered on the bigger circle B. Now supposing if capital B is the mean position of the planet and if small b is the true position of the planet, now we can go for finding out the x coordinate and y coordinate of the point B. And if we consider the equation of a circle, we know that equation of a circle centered at origin radius r square by x squared plus y squared is equal to r squared. So that can be fit into the equation of the circle, which finally simplifies to mu squared plus 1 x squared plus 2 mu mod xy plus y squared equals r squared. Next slide, please. Now comparing this with the equation ax squared plus 2hxy plus by squared plus c equals 0, we get the values of a, b, h, mu, that is a, b, g, f, and c. Now if you go for substituting in the matrix determinant ahg, second row hbf, gfc equals 0, that is substituting for ahgbf, then we get the value of the determinant simplifying to minus r squared, that is not equal to 0. If the determinant becomes 0, we can claim that the equation we have.
Yeah, you sum up in 2 minutes, please.
Yes. But because it is not equal to 0, we can conclude that it represents a conic section. And also we know that if h squared is less than AB, conic section is nothing but an ellipse. So since we have h squared is less than AB, we have h is equal to minus mu, A we have it as mu squared plus 1 and B is equal to 1. So obviously here we find that h squared is less than AB, and hence we have the conclusion that this simplifies to an ellipse. This we have done it under the guidance of our professor Dr. S. Balachandra Rao. Now actually the Indian system, most of the Indian astronomical text takes the variable periphery, and it is in contrast to the Ptolemy and other Greek astronomers who take the constant periphery. Even they have postulated epicyclic model, but their epicyclic model is totally different from our Indian system. In fact, this variable periphery leads to the elliptical orbit. Now, next slide, please. And possibly because of this fact, we could arrive at the values that are comparable to the modern ones. Now we have the reference to the ellipse prior to Mahaviracharya. Now Mahaviracharya uses the word Ayatavritta to represent the ellipse. Now in the verse, I don't go to read the verse, I'll just translate the meaning of it. This means, he tells that the area of the ellipse is given by the expression that can be understood by a modern student. And one more verse is here. The above stanza means that the square of the short diameter multiplied by 6 and the square of the twice the longer diameter is added to this. So if you put it in a mathematical form that could be understood by a modern student, that means the circumference of the ellipse is under root 24b squared plus 16a squared. And this I've taken it from Ganita Sara Sangraha, authored by Padma Uttama, chapter 7, shloka number 63. Next slide, please. We have reference to the ellipse prior to Mahavira, that is in Rig Veda. I have made mention to the reference in Rig Veda. Now the verse translates as zodiac, unlike a circle, which is only one center, has 3 abhyanis, which means that there is a center and 2 foci. Thus, there was a clear concept of ellipse in the Vedic period. Next slide, please. Also, Vyasa in his Srimad Bhagavata refers to Arohana and Avarohana. Arohana here means earth moving away from the sun. Avarohana means earth coming nearer to the sun. And Samanyata means average distance. If the earth has circular orbit around the sun, it is impossible to speak of the Earth moving away from the sun and moving closer to the sun and the mean average distance. So it is very clear that the concept of ellipse was there during the period of Srimad Bhagavata also. Next slide, please. And also in Bhagavata, Vyasa quotes as Anda Madhya Krataha Suryaha. That is, sun is at the center of the egg-like space of the solar system. Such statements have been repeated in Bhagavata. Thus, the concept of ellipse is originated in Veda and further clarified in Purana. This is the history of the concept of ellipse. All these details I have collected from Saraswati Amma, who has authored Geometry in India. And this is all about my presentation, sir. Thank you. Thank you for the organizers once again for giving me an opportunity to make my presentation.
Thank you, Dr. Padmaja.
Thank you, sir.
Questions from the audience. We have 2 minutes time.
Yes, sir.
I have a small query.
Yes, sir.
Dr. Padmaja.
Yes, sir.
Dr. Balachandra Rao is co-author in the paper.
Yes, sir.
Is that right? He is one of the authors.
Yes, sir. We are working as a team.
Somewhere I saw written courtesy Dr. Balachandra Rao.
Yes, sir. That concept was.
Is it okay?
Yes, sir.
When he is one of the authors, so how do you write?
Okay.
Courtesy Dr. Balachandra Rao.
Should I not?
I mean, technical point. That's all.
Okay, sir.
Yeah. So, any question from the audience?
Just one question. At the very last line, she is writing courtesy Saraswati Amma. So, is Saraswati Amma, is she just a goddess Saraswati, or is it?
No.
Mathematician.
Mathematician T.A. Saraswati, who written a book, Geometry in Ancient and Medieval India. Geometry in Ancient and Medieval India.
Yeah.
T. Amma Saraswati.
T.S. Saraswati Amma. She has authored the book Geometry in India.
Oh, okay. What was the time period? I missed that. When did she write this book?
Probably 19th century. 19th century. I think
the book published in 1979. The book was published in 1979 by Motilal Banarsidas.
Okay, thank you. Thank you.
Yeah, we have one hand raised by Ajit Kumar Benani.
No more.
Ajit
Thank you so much.
I think somebody is speaking who is not on mute. If you can please be on mute.
I muted them.
Dr. Bhandari wants to ask some question.
Yeah, Dr. Bhandari, please ask your question.
You mentioned that this sun is the center of a elliptical system, and this was known for some 5,000 years. This is true. And then again, you said that Mahaviracharya calculated the parameters of ellipse to find out the orbital paths of various planets. So is that correct? I mean, I was under the impression that these elliptical orbits were known much later.
Yes, sir. Mahavira never calculated the elliptical orbit. He just gave us the perimeter for the ellipse, sir.
You said motivation was about the...
We have, that is modern mechanics. As a modern mechanics student, we could take the motivation because that was the perimeter of the ellipse. He had given the formula, which no other Indian astronomers have thought of them.
And that the sun is at the center of elliptical system. That was known from Bhagavad Gita, you said.
No, sir, that was given in T.A. Saraswati Amma's Geometry in India. I have taken the input from her text.
But is it correct?
I'm not sure, sir. I've taken it, but she is an authority in geometry in India. So I thought whatever she had mentioned in the text must be correct, and so I have included that. Sir.
That's good.
To verify that.
It is a big, discovery if it is true, because I thought these were known much later.
Because T.A. Saraswati Amma is a respectable scholar, and I think only after verification she would have included in her textbook. Further, I need to what do you say, to support my argument with some other comparison or some other information.
This can be done. It's not difficult, but one can be done little later. Thank you. Thank you so much.
Yeah. So
let's go.
let us thank Dr. Padmaja for
Excellent.
a very interesting,
Excellent presentation.
excellent talk, and it generated certain discussion, and that is the beauty of a talk, that it should generate some discussion. We have two more speakers. Our last but one speaker, Dr. Balram Singh. Dr. Balram Singh is working in what is that? Botinum Research Center and School of Indic Studies, Institute of Advanced Studies, Dartmouth, USA. Now, Dr. Balram Singh will be speaking on karma vibrations of consciousness for mathematical estimation of consciousness. So may I request Dr. Balram Singh to please give his talk. Dr. Balram Singh, please.
Thank you, Dr. Agrawal. At least the spelling, the Botulinum Center is kind of difficult because not that familiar word. Normally people know through Botox. Thank you very much, Pankasaji, who gave me this opportunity, and of course many friends, Sulekh Jainji and Praveen Saji, and also Dr. Vimel Prakash Jainji. They're all good friends, and I'm always been happy and welcome to visit their temple, Jain temple in Greater Boston area, where I normally take some teachers. So I've been very lucky to be exposed to the philosophy, and what I'm going to present is, as a result of that, I learned something. So next slide, please. I'm the purpose that, oh, this is older slide I think you are putting up. Can you put my newer slides, please? I send the
This is the what we just got a few minutes ago.
Can I share my slides then?
If you
can you allow me to share my slides?
I think Devbhai or Harish Bhai.
I think you should be able to do it.
Okay, please allow him to do that.
Balramji, you should be able to do it now.
Okay, thank you. Thank you so much. Thank you. All right, so I should be getting the first slide, I hope. Not there yet. This is not where I wanted to start. A tour of my slides. Okay, there I am. So thank you again. From what my understanding is, of course, mathematics, and there have been several very interesting questions as to why, how is that connected to Jain mathematics? I mean, mathematics is mathematics, I think is secondary. Jain, to me, it's from what I understand is the philosophy is primary. And when we make some food, I mean, hardly be ever weigh out the salt that we add. We just have a sense of it. And so that's the level of thinking of many of Indian traditions, particularly Jains, have had that, the ideas that they have brought out that people need to have mathematics for communication. So that's how I think about it. Now in Jain thought, there are a lot of great ideas, and this is not the place, obviously, for me to talk about. But they have these great ideas of how they have Jiva and Daya concept, giving up material world for peace, and these are very spiritual sense in there, and then how they value the different lives. But important thing is that what I find in here, and I still see some practice. Not all the Jains, but at least some Jains do give up everything, including life, willingly. And so this setting, the concept that I got from Jains is the setting of karma. Normally, I always understood that karma is something that you need to do, but you need to do to get rid of it, which means you need to get out of all this and reach to nothing label. And that nothing label can also be considered that it's everything. And that is the concept from Jain philosophy that I have learned. And I'm going to use that to see whether we can use that concept, use mathematics to get to the understanding the other way around, not getting the mathematics out, but using mathematics in. And one of them that I like to highlight is this karma. The karma is a transformation, is a beautiful idea. Of course, this is spoken by many traditions in India, but more clearly that I learned is from Jain philosophy. Karma is transformation of the material objects caused by the self, and also at the same time, it is the transformation of self caused by the material objects, which means they combine them to be one, the concept that I talked about earlier. This is the interesting thing is that they point out that which is performed out of result of vibrations of self is called karma. This gives the concept of some physical material exhibition of the karma, and it makes self-dependent. That means self is the one which is vibrating. And then they talk about very minute particles, which you can compare with today's, subatomic particles or whatever that know today that the world is made of. But the real idea that comes again back from them is that the origin of manifested mind and matter. So it's mind and matter is the one which is playing. And whenever we talk about matter and when we talk about mind, then there is a question of time and space. And that is the one which defines then periodic motion that we see from whatever discussion we have had, talking about all the movement of planetary movement, galaxies, and anything that moves in Earth, including subatomic particle, everything is moving. And that gives us a beautiful concept to look at the world and then try to understand what Jain sages and others also in Indian tradition, they try to get to. So it's not the question of trying to create mathematics, but using mathematics to get to where we want to get. And so the mathematics is not the real issue. You can find mathematics in calculators, you can find in your mind, you can write it. Is it learning to smart or smarting to learn? And what many times people think that mathematics is smart, but actually using mathematics is to get somewhere is more important. And which is what, it's not that I'm very smart about it, but I think I like to do that way. And that helps me understand myself and others. So for example, we talked about the Jain philosophy, again, Karma Yoga philosophy that Swami Vivekananda also talks about the same way, is that you give up everything, let get to the zero. And then, but then you realize that plus zero, minus zero is what is really the theory of economics. And it's not just the economics in here in English, but in Sanskrit, it means earth. That means the meaning. You understand the whole world by this giving up everything and getting to the zero that, I just talked about in Jain philosophy. And so that the Sunya concept, the dot that symbolizes the Sunya, this open circle that goes, the way it has been written, although there are many people claim in this world, whatever, but it is fairly accepted that the concept of zero came from India. But how it is written is also very important. So Sunya is zero, nothing, and also is everything, because there is no beginning or end of it. So mathematically, it is the Sunya that that represents this entire universe. That's the concept, philosophical concept. Many times in physics, people are thinking a lot of things, especially about Vedantic society, Vedantic concept. They think that quantum is the one which reflects. There is some truth to it, because in Vedanta also people say that, things just appear. They do not have to go from one place to another place. And that's why I think the idea of removing the concept of time and space, they're talking about that. But actually that is very different and sometimes actually dangerous from philosophy of either the karma theory that I just talked about, or even Vedanta society, Vedanta philosophy. And so it is not the material that is moving around, which is the quantum considers. They consider the material that is really having all these discrete energies and differences and space and time. But the idea is in Indian philosophy systems, including Jain's philosophy, is that the mind is that important. And that mind needs to be explored further, which is what I will try to do. So, I heard a lot of mathematics, particularly this morning, and that is an approximation. There was talk about some approximation of this, and then you can get the real. Well, there is integral calculus, which also approximates, but the theory of calculus in here is minus infinity to plus infinity. I'm not a mathematician, I'm a chemist, but mathematics people will agree, but then we have to limit, because then we limit based on our own senses. So it's never really a perfect one. And that's what I'm trying to get to, is the consciousness, which is really the perfect, not the mathematical representation of it. Can we get closer to it? Probably. So that's how precise you can be, how accurate you can be, how much you can resolve. It all depends on human beings and technology. And I'm probably going to skip this, this slide, because this is a little bit complicated and may not have enough time to go through, except the point I want to try to make is this: when you use different kind of tools, and those tools then give you certain readings. So this is, for example, being a chemist, I'm looking at naphthalene, and naphthalene has excited states, it absorbs light, energy, and then gets into some states. But it is not exactly, even though these are all resonant structures, but they are not exactly the same. They all have a little bit difference, and then you can see those differences reflected in the spectra. Just like we as human beings have, that we have our own, let's say, karma, some kind of vibration, and then we look different. But to get to the final stage, we have to give up all this, and this can be tested. This is the point I'm trying to tell. This can be, there is a great thing. This is all related to quantum. And it's some area of my research. I do spectroscopy, biological spectroscopy. And then, so I try to correlate this, that it is this vibration that is really causing all this. When you give up the vibrations, as in Jain theory, it talks about, then you completely become free from the bondage. And then you reach the final stage, which is what is very important. There is a set of experiments have been done. That was published in Science in 2006. That, when conscious life is not that perfect, actually that's not actually even that real. This is an experiment of buying cars with only considering 4 aspects versus considering 12 aspects. When it becomes 4 aspects, yeah, you can do some thinking and rationalization. When it becomes 12 aspects, actually it's all unconscious decision. When say unconscious means irrational, mathematics go out the window. This is something that you get into your own head. And that is very important challenge for mathematicians to get to this one. So what my group has done is created this model, consciousness model, and then trying to get, using mathematics to get to that. And that model is something that we are trying to get with some assumptions, of course. That's how science moves forward. The consciousness is all pervasive. That is, again, bringing the concept of Jain philosophy, where when it is everything, then it's a complete consciousness. Expression of consciousness can be represented by vibrations. Different things may have different frequencies of vibrations. A vibrational frequency can be defined as periodic change in signal in any of the infinite dimensions of consciousness with respect to another dimension of the consciousness. I'm just trying to set it up so that I can use mathematics. Vibrations are natural to all matter and non-matter components. I add the non-matter in it. because to get this concept of beyond all these vibrations, and then universe and para-universe. And so mathematically now I have set it up with assumptions to create this model where I'm assuming consciousness to be represented by space versus time. Signal in space will increase in frequency with decrease in time. That is, shown in the in my first left of the corner of the picture. And as the time reaches 0, the signal will become all pervasive. When the time becomes 0, it's all pervasive, you get the consciousness. Similarly, you can do the same thing to space. With increase in time, increasing the space, wavelength goes very large, and then ultimately it becomes all pervasive. The wavelength becomes all pervasive. In either case, the amplitude of signal remains constant, irrespective of variation in time, and contraction and expansion of time is thus defining factor attained consciousness. And then our hypothesis consciousness is general concept of existence of any and all things known and unknown, and is universal. The consciousness in its ideal and complete form is experienced equally by everything, including human beings. So human beings, again, this is Jain concept that everything has the consciousness, and we need to respect not just human beings. Awareness of the consciousness occurs with limiting the consciousness to one or more of the infinite dimensions. Then you become, oh, I know this, I'm going here and I'm going there, including space and time. At any one of these limitations is reflected in mind, which acts as the relativist of the human being. So the mind is actually very low level of trying to understand things. Consciousness is very high level. Mind is form of energy that changes frequently with time and space, and in any other changes in the universe by being integral part of the consciousness. The relationship of mind and with time and space opens the possibility of its examination by tools of modern science, which is primarily the study of matter as a function of time and space. With this, one more aspect of the model that really allows us to do some calculations is this model says that how the mind's perception of time changes with respect to one's consciousness. The center represents the total consciousness when there is no time and space. The center represents the consciousness, complete knowledge or truth. Radius r is amplitude of ignorance. The far away you go from the center, then you have more ignorance. The mind's perception of time corresponds to the length of the arc, how far you have to go further. Somebody who's achieved nirvana knows everything, does not need to go anywhere. The time means nothing for them. For us, it is a very, very long time. While the angle and actual measure of time stay the same, the mind's perception of time and the length of arc both increase. Further to this, from the physical world, and closer one gets to the total consciousness, or you can say God, those believe in God, the less time and space matter even exist. This also suggests that the time and space matter less. One is closer to total consciousness. This means that the center of the circle is in fact the total consciousness or God. I will not go into more detail about this, but I have used this idea of time as an important thing and then trying to find something that we can measure this. One of the concepts in physics is the kinetic theory of gas, where you have the velocity being affected by temperature. Velocity has time and temperature has heat. And so that we can, as human beings or any matter will be affected by that. And so I have used that to define a concept that is called consciousness coefficient. And that can be estimated for each individual and entity experimentally. This is this consciousness coefficient. I'm making an assumption for a human being, which is m to be 1.4 kg is the brain size, the distance being those many meters of, let's say, 75 years, and moving with the speed of light, and then get the R value. Then we have calculated the consciousness coefficient of a totally ignorant person would be 5.054 times 10 to the power 17. The important thing in this, very important thing in this, is that normally in science, including chemistry that we have a universal gas constant, for example, R. It applies to everything. In this calculation, we think every individual has their own constant. which means again the karma theory fits in here because everybody is different, and which I think even modern science and modern medical science particularly is recognizing that every individual is different. And so this means that everybody can have their own consciousness coefficient and then can work through as they do yoga or meditation or whatever kind of activity they do. They can improve that and they can monitor it, and hopefully they will get to a stage of nirvana or something like that. This idea is I also got it from an experiment that Einstein did, where he very simply explained something that anybody can understand. It says, and he published in Journal of Exothermic Science in 1938, says, when a man sits with a pretty girl for an hour, it seems like a minute, but let him sit on a hot stove for a minute and it's longer than any hour. That is relativity. This is the concept that can be used. I am presenting here, this is one more slide to go quickly. I'm presenting this one here, the scientific aspects of the concept that are in Jain philosophy or in general Indian philosophy or Indian culture. That is very important because sometimes we are talking about, many questions came and I did not intervene those, but many questions came and how does it fit with the Greek? How does it fit with that? And the reason it does not, and it's not, I mean, it's okay to compare, but not try to meet it because your concepts are very different. And this is based on this. This guy, Werner Heisenberg, who, by the way, got Nobel Prize for Heisenberg uncertainty principle, just basically telling that you cannot know things, he got Nobel Prize for. And he has written a book, and he was influenced, by the way, by the Indian philosophy. And there is a foreword written by a philosopher of Yale University, for Professor Northrop, and he explains how the science works. It's very important. So when we talk about Jain mathematics, Jain science, we need to think about Jain more important. Science will come later. So here says the instruments of modern science derive from its theory and require a comprehension of that theory, for example, like Jain philosophy. This theory rests on philosophical as well as physical assumptions. When comprehended, these philosophical assumptions generate a personal and social mentality and behavior quite different from, at points incompatible with, the family caste, tribally centered mentality of native Asian, Middle Eastern, and African people. This is where we are dealing with when we want to compare. We don't need to meet. We need to sometimes contrast, and we need to maybe improve. We need to maybe integrate, incorporate, and that is going to be more important for some of these great philosophies that come from India to move forward and help the humanity. Thank you very much again for giving me this opportunity.
Yeah, we have time. Any questions, comments?
Yeah, I have a question. This is Gandhi Mardia. Hello. My question is, Roger Penrose had his own model of consciousness, and how does this fit in with what is called quantum soul? Any correlation, or is it?
Yeah. So as you could imagine, I criticize the quantum. Many people, one of the I mean, and somebody who works with, I mean, one of the applied quantum mechanics is what I do. I do a spectroscopy, and which is all based on quantum, and that's why I was trying. I did not go into detail, thinking of the audience, but the spectroscopy assumes that everything is discrete. The matter is energy, and energy is discrete. And then when you do the spectroscopy, you convince yourself, and that proves that there is a quantum. And many times, almost all the time, Indian scientists, intellectuals, and spiritual people embrace this. They're thinking that, oh, we have really met. But this is what I'm trying to warn against. Not to embrace something that is very limited, because science keeps changing. Some of these ideas that the great sages or the people who have attained certain status in consciousness is going to be very different. Just like I started by telling that how many of you really weigh the salt that you add in the food? Not, I don't, I do cooking and I do not, because we have a sense of it. The sense is very, very important in my opinion. And so the quantum actually is a degradation of these consciousness idea to be explained. Now, to certain, just like to babies, give baby talks, we can talk to scientists like that, but not try to prove these great philosophies by that. And that's the only difference I have.
So just to continue, because I have had some conversation with Penrose in Oxford University, because I am also professor there. So one of the conversation was that, what went long, but roughly that I said, you are quantum soul and we, Jain, believe in karmic soul. So the karmic soul versus quantum soul, I was trying to convince him. Of course, I couldn't, but but I had a go at him, giving a various idea of karmic particles or karmons, as I call the way I describe. Well, I enjoyed very much your talk. I think it's a very forward-looking and visionary. Well done.
Thank you. Thank you very much.
Dr. Balaram Singh, I have a small query, please.
Sure.
You said you developed mathematical model.
Yes.
Am I right? So I just wanted to know what type of mathematical model you developed. Was it some set of differential equations or difference equations or something else?
I think whatever I'm just presenting, when I say mathematical model of consciousness, what I'm trying to do, yes. So it will be a differential equation. It will be actually more, because I will be what I'm interested in like I did not go into detail, and I want to do experiments and prove it. I want to really work with people and find it out. But mathematically what I want to do is I want to get that area, the arc, that as R goes high, then arc becomes bigger, and I need to do the calculation of the area, and that I will be doing using the integration methods or some other approximation methods, and that's what I want to do.
Maybe integral equations or differential equations are involved there.
True. That's what.
Wonderful. Excellent. Highest level talk by Dr. Balaram Singh. I think all of us will agree with that. Excellent.
Very much.
He's a very respected scholar within the Indian community, not only in the Boston area, but all over the United States. And I have had chance to meet with him, interact with him, and we respect him. So, Balaram bhai, बहुत धन्यवाद आपका. And
thank you very much, Dr. Balaram ji. Thank you very much. Wonderful talk.
Thank you.
We enjoyed. And we enjoyed the fact that you tried to make a model, mathematical model for consciousness and karma, etc. So, well, wonderful. Thank you very much.
Thank you.
Our last speaker is no less than Dr. Anupam Jain. Dr. Anupam Jain, I think everybody is familiar with Dr. Anupam Jain by now, from Indore, associated with this symposium, and a very respected Jain mathematician in India and perhaps abroad as well. So, Dr. Anupam is going to speak. He is working as Professor of Mathematics and in charge principal, Government College Sanwar, Indore. And he will be speaking on Treasure of Ancient Jaina Mathematical Wisdom. So you can see already on the slides, number of books, etc. Anyway, I request Dr. Anupam Jain.
Thank you, Professor Agrawal. I would like to please check the slides. This seems to be older one. Next one. See, this seems to be older one.
Looks like.
Correct. Yeah, correct. Sure, correct. So, first one. Go back. Yeah. Now the question just raised by Professor Balram about the nomenclature Jain mathematics. We are not intended to say that mathematics is less and Jaina is more important. But in fact, the situation is this, that the mathematics found in Jain canonical literature to explain the philosophical thoughts are the mathematics used to explain the karmic structure is known as collectively Jain school of mathematics. It is not as a branch of the mathematics like algebra, geometry, analysis, but the collective name to find out, to give a number, to name the mathematics which is available in Jain canonical literature, either written in the early century or the commentaries written afterwards. To explain the canonical literature and the facts which is available in the Jain canons, some independent text also written by the certain scholar, they are Ganitsara Sangraha, Pati Ganita, Ganitsara Kaumdi, etc. They also come under the nomenclature of Jain mathematics. So we are not intended to give less weightage to mathematics. We give proper and complete weightage to mathematics, but whenever we accept the Greek mathematics, Chinese mathematics, Japanese mathematics, Indian mathematics, I think there is no harm to accept the Jain school of the mathematics. Now, in this seminar, in this symposium, we are listening the scholarly articles, scholarly presentation from last 2 days. Then there is no need to explain much about the role of mathematics in Jainism, classification of Jain literature, but I would like to explain, give some light on the purpose of the developing mathematics in Jainism. Next slide. Next. Next slide, please. Yes. Purpose of developing mathematics in Jainism: to explain cosmological details and the description of the threefold universe. It is used in giving the length, area, and volume of the different section of the threefold universe, mainly of the different mountains, river, and parts of our Bhuti. In fact, whenever Jainacharyas tries to explain the structure of the cosmos, they used mathematics as a tool, and it is well explained by the Professor S.G. Dani in the first talk of first day. Second, to explain different types and subtypes of the karmas, their operations of uprising, binding, and shedding of karmas, and the net effect of their infinitude combination. Professor R.S. Shah discussed so many things, so many formulas related with the combinatorics, binomial expansion, and other expansion, which is collected by Professor Shah from Jai Dhavla and Dhavla commentary and the canonical literature, explain this thing and prove this thing. So whenever there is a discussion regarding the Karma in Karma Granthas, in Dhavla, in Jai Dhavla commentary, Gomatsar, Jivkand, Karmkand, we find that there is a lot of use of the mathematics in Karma Granthas and explaining the karmic model. And third one is to get auspicious place in time for the religious ceremonies like Diksha and Pratishtha. This is very clear. And in ancient India, astronomy is dominating and mathematics was a part of the astronomy. So so many astronomical texts available which are published or unpublished at present prove this thing, that in Jain school of mathematics there is a lot of role of astronomy. And the fourth is to train the people's householders in basic mathematics required in the daily life and also used in the construction of temples and houses. The book like Ganitsara Sangraha, Trishatika, Ganitsara Kaumdi, Ganit Tilak, all are those which are related with the Pati Ganit are related under and come to this very category. Because whenever we build a temple, we build a house, we must require the mathematical knowledge and to explain Jain logic system, which is used for the establishment of the logical facts and the reconcilement of the others' views. In fact, the article of Professor Mardia related with the Jain logic, which is presented by Ruda, and the presentation of Anupam Jess, both prove this thing that mathematics also used in the Jain logic, and which is known as in Jain tradition Nyaya Granthas. Next. But today I will emphasize on the exclusive class of the Jain mathematics, and we will give some information about the published and unpublished mathematical texts of exclusive class. Sulekh Bhai, in the very beginning of this second day, he said that so many Jain texts are still laying in the different bhandars and they are waiting to be published and come before the academic world. So far, in spite of the many efforts made by several scholars from B.B. Dutt, A.N. Singh, T. Amma Saraswati, L.C. Jain, we can publish only 8 very important mathematical texts, which are listed here. Trishatika of Sridharacharya published in 1899 by Sudhakar Dwivedi. And Ganit Sar Sangra, 4 or 5 papers are presented today. And this is Ganit Sar Sangra, which is written by Mahavira Acharya in 850. The internal evidences, which is available in the Ganit Sar Sangra text 2, prove that it was written during the period of Amog Varsh Nipruti. Question raised about it. So internal evidences are available in the Ganit Sar Sangra that indicate that it is composed during the period of Amog Varsh Niprutung, and the period of Rashtrikut Niprutung Amog Varsh is fixed 814 to 877. Therefore, Mahavira Acharya safely placed about 850 AD. And the third one is Ganit Tilak, commentary on the party Ganit of Shripati, and written by Sim Tilak Suri. This is written by 1275 AD, and it is first published by Oriental series Baroda in 1937. In fact, in 1 year before, in 2019, Alisandra Petrocchi completed his PhD on the Ganit Tilak from the Cambridge University, and which is published by some publisher of UK. The Vyavhar Ganit of Rajaditya, that is published in 1955 by Madras government, and now it is again published by Professor Padmavatanga with Kannada translation in 2012. Ganit Sar Kombi of Thakkar Feru, Stang Panchvinshatika of Tej Singh Suri, it is published by Takao Hayashi in Ganit Bharati, and Leelavati of Rajaditya, then again Kshetra Ganit of Rajaditya. This is the recent publication in 2019. So these 8 books of exclusive class, most of them are related with mathematics, but some are related with the astronomy too, has been already published with critical edition, and in translation, comparative study, notes, and introduction. But 4 texts are such with only text has been published, no translation is given: Angul Saptati, Leelavati of poet Lal Chand, Ank Prastar, and Jyotirgyan Vidhi, that is of Sridhar. So these are some work. The present respect of Jain school of mathematics is based on in exclusive club only on these 12 books, but a large amount of the book are still unpublished, and we do not know even the name of these books. So next please. Yes. So unpublished text, I have prepared a list of about 40 such manuscripts which are laying unexplored, unidentified in the different libraries. I want to draw the attention of Sulekh Bhai that he is saying that there are so many manuscripts which are laying in the bhandar. I have prepared a complete list of that very manuscripts, name, their period, and the name of the library Bhandar where it exists. So this list is given, and if we want to conserve the Jain literature related with the mathematics, then it is first our this is our responsibility to collect these manuscripts, to get the digital copy of this so that they can be preserved for a long time. Next, please. We have given here only 22 names, and regarding so many Kshetra Samas, so many Kshetra Samas, Kshetra Samasavachuri, Lag Kshetra Samas, and their commentaries written by Som Tilak Suri, Gunaratna Suri, Ratna Shekhar Suri are available in different libraries. Next. And not I have prepared only the list, but I have collected certain manuscripts, and we have given the copy of one page of that manuscript. For example, Trishatika of Ganesh Sar Sangra, which is also known as Ganesh Sar, has been published, but this published version has only 170 verses, 170 shlokas available, because it is in Sanskrit. And here we have got a manuscript from Moodbadri that is in Kannadi script, but it is in Sanskrit, but script is Kannadi. And this manuscript, which has the 26 folios, have 300 shlokas. Next. This is the Jyotirgyan Vidhi. Pankaj Bhai is working a lot in the field of the astronomy. This is a very old manuscript, Jyotirgyan Vidhi of Sridharacharya, and we have collected two copies, one from Ara, another from the Pannalal Saraswati Bhandar, Ujjain, very near to Indore. And this has 10 chapters and a very detailed information about the astronomical knowledge which is available in the 8th century in India. And these we have collected, but there are several other manuscripts also available. One is in Ara and another is the Moodbadri. Next. This is the Shat Trinshika. 4 papers are devoted to Mahavira Acharya's Ganit Sar Sangraha. But from the efforts of National Mission for Manuscripts, more than 200 manuscripts has been collected and reported to the National Database of NMM. Here, all the more than 100 manuscripts are reported as an incomplete manuscript of Ganit Sar Sangraha. But out of them, we have collected 2 manuscripts from Jaipur. And these 2 manuscripts are really extension of Ganesh Sar Sangraha. Madhav Chandra Trivedi, who is the commentator of the Trilok Sar of Nemi Chandra, is written this book with the extension, the 4 chapters of Ganesh Sar Sangraha. Someone raised the question, what is the language of the Ganesh Sar Sangraha? So I am reciting the Mangalacharana. Alangam Tajikasaram Yaschanam Chatushtayam Namastasmai Jainendraya Mahavira Itaine Sankhya Gyan Pradipena Jainendrena Mahotvisha Prakashatam Jagat Sarvam Tenatam Pranamamyam. This is the Mangalacharana of the Ganesh Sar Sangraha. So whenever we see that Mangalacharana, we say this is Ganesh Sar Sangraha. But in fact, Uttar Chhattisi Tika, Shat Trinshika and Shat Trinshatika all are written by the Madhav Chandra Trivedi with an addition of a new chapter in the Ganesh Sar Sangraha. Next. These are the 13 new sutras are available in Shat Trinshika, which is written by Madhav Chandra Trivedi. And this is important, a magic square of 34 is also given here. Next. This Lokanayog, in fact, Harivansh Purana of Acharya Jain has been published, but the 4th, 5th and 6th chapter of the Harivansh Purana is completely devoted with the structure of the cosmos, and this is a elaboration of the details which is available in the Harivansh Purana. So the new name given by the Jain itself is Lokanayog. Next. This is a manuscript Trilokya Deepak by Pandit Vamdev, and this is so popular. Jaina concept of the Lok and the details of the cosmos is so popular that the non-Jain scholars also written the commentary on the Tiloy Parnati and the Trilok Sar, etc. So this is Trailokya Deepaka Pandit Vamdev. Of course, it is in Sanskrit. Next. This Trilok Darpan of Khadaksen, this is written in the Hindi and Devanagari script, but it is totally based on the Trilopanati and Triloksar. Next. Yeah, next. The Ganit Sar, this is a very wonderful book. The details of classification of numbers, which is illustrated by Dr. Jitendra Sharma yesterday. These 11 type of Sankhyat, Asankhyat and Sankhya, Sankhya, Ananta ke, Ei Bhedi Kis, Yatha Shakti Varnan Kiye, Suksham Jane is this type, this book, Ganit Sar Sangrah, found in Ganj Bosada, Vidisha and Bundi of Rajasthan. So this is a very important manuscript which is give details of the number theory and how we get the uncountable number from the countable number and what things should be added to get the uncountable number. All these details are available in this book, which is, I think it is the first Hindi text, first mathematical text written in Hindi in Devanagari script. Next. Yes, this is the Mahimodra's Ganit Satso. Ganit Satso is available in Surat and also available in Bikaner. This is a very important text of the astronomy and it deals with the mathematics too. So I have given here one copy, but more copies are available with me. And this is Anand Kavi, Ganit Sar of the Anand Kavi. Ganit Sar name is very popular. Very popular. So many Ganit Sar has been written by the different author, and this is written in 1674. Next. There are some more manuscripts. This is Uttar Chhattisgarh Tika. In fact, there are several objections raised before the work of the Mahavira Acharya. One serious objection is raised by the Catherine Morris Singh that the English translation of the Ganit Sar Sangrah, which is very popular and it is published by Madras government in 1912, is not perfect. Catherine Morris Singh said that he omitted certain things during the translation process. She checked the old manuscript in Oriental Manuscript Library, Chennai, and what are the objection which is raised? I think the comment is, this is the commentary on Ganit Sar Sangrah written by Bhattarak Sumati Kirtiji and several other manuscripts which I have collected from the Koba, very old manuscript. So on the basis of these manuscripts and the copies which is available in Oriental Manuscript Library, we can prepare a new revised version. And if there is any mistake made by Rangacharya, knowingly or unknowingly, then it can be improved. Because the Hindi, Kannada and Telugu translation of Ganit Sar Sangrah are totally based off the Rangacharya's edition. Now here I am giving some more Lagu Sangrahani, Sangrahani Sutra, Balabodh, etc. So there are 10 more manuscripts with me, which I have collected, and it should be next. Now our responsibility is to get the copies of these manuscripts from the Bhandars and print the at least facsimile. In 1988, I have published the facsimiles of Stang Panchvinshatika, and whenever Takao Hayashi of Japan got the facsimiles, he translated it. So if we are able to publish the translation critical edition, then it is very fine. But if it is not possible at this moment due to the lack of the scholars who can understand the thing, who can translate the thing, then at least we publish the facsimile or we publish it on the internet so that these can be translated some time later, to put the Jain mathematical contribution before the academic world in right manner with all necessary references so that the scientists may take vision and help from it to solve the problems of the nature and work for the betterment of the mankind. Jain Acharyas is not intended for the development of the mathematics. They are intended to explain the philosophical thoughts, and they used mathematics as a tool. Just how mathematical, in the modern age, we use mathematical model. Mathematical modeling is what? Mathematical modeling is the representation of the real world. into the mathematical form so that it can be solved with the help of the available mathematical techniques. So Jainacharyas used the mathematics to explain the different things. They have written the exclusive mathematical text for the betterment of the mankind. They have their historical importance. Simultaneously, they are able to solve the current problems of the mathematical world too. Infinite paradoxes are well known. We have a detailed information of infinity, classification of infinity. Cryptography is a very important branch. The Siribhuvale is the only text which is written in the number script of 27 by 27 manuscripts. So these type of work which is done by the Jain Acharyas for the betterment of the mankind should be published, and it will help the mankind and it increase the knowledge of the academic world. Thank you.
Questions.
Dr. Agrawal. Dr. Agrawal, with your permission, I'd like to make a few comments. Number one, I'm very grateful to Dr. Anupam Jain. He is not only a museum, but he is also an inspirer. And the reason I'm saying this, I want to make some positive comments. Number one, Anupam Bhai, 16 years ago, you are one of the founders of the IASJS, International School for Jain Studies. Today, it has mushroomed. 700 people from scholars from here, many universities have gone to India to study Jainism. Nearly 25 people have already done PhDs in Jainism from Harvard, Yale, University of Chicago, many others. We are filling our position in Jain academic education here from those scholars. Now we have plenty of them. And that many more are doing PhD at SOAS and many other places. Here are a few things. Number one, since you are the part of that starting the Jain IASJS, we will create a special institute under IASJS. You will be the director of this advances in Jain mathematics. You will coordinate all of these activities. Dr. Abe Ferodia's resources are there, okay? And we are hiring quite a few people in IASJS right now. The advertisement will be going out. That's number one. So this is a very positive trend that I want to catch up on that one, not let it slip. We will provide all the resources, even funding, whatever you need, okay? Number one. Number two, our Praveen K. Shah, who is the director of the Jain IE library, huge amount of information. He has texted me and is sending through this chat box. He will like to take all the material, including LC Jain's material, any other material that you can provide. He will upload that on Jain IE library. So please work with him. We all know Praveen K. Shah, you know, and our complete resources are open. So we should lead this effort, bring a new chapter to this Jain mathematics, okay? And upload this information, make it available. That's all I wanted to say. Thank you. Appreciate it. It's very uplifting. Now, Dr.
I'm in touch with Ferodias, and 3 years back, there is a meeting on Naval Virayatan in Pune. I attended that very meeting in the planning of the museum. That's a big museum. And now I'm in touch with Shugansi Jain and planning to meet with Ferodias to assist him and to provide our services for the betterment of ISJS. Regarding the Jain IE library, we are associated with Praveen Bhai, and we have provided several books for uploading on the Jain IE library, and the Jain manuscript which I have collected will be provided to Praveen Bhai for uploading on the site so that it can be preserved.
Very good, very good. Now, Dr. Agrawal.
Yeah.
Hello. Hello, can you listen to me? Hello?
Yeah.
Okay. Well, this was very, very interesting and I would say educative. But all these books are in Hindi or Sanskrit. Am I correct?
Yes.
Okay. I think we need to undertake some kind of an effort to translate some of the important books into English. Otherwise, they will remain as they are. they were whether in USA or in India or anywhere, they will be still staying just like unknown before. If you put them in English, perhaps it will be better to read them. Most people can read, and we can definitely recommend people. And there may be people who want to do even PhD on that.
Can I add something? Just 1 minute. What I want to add, they are not all in Hindi or Sanskrit, but there are more than 4,000 books in English. Okay. Total, there are 25,000 files. We have it. More than 4 million pages. Okay, that's what we have done. Whatever people requested it, we have a good access to libraries. Okay, so generally we never had a hard time to find the books. Okay, there are so many people support us, so there is not any problem for getting the material and putting it on the e-library. And e-library is a non-commercial and totally free. So that's the just point what I'm trying to bring it out.
Yeah.
Any information which is not a copyrighted, I'm talking no after 60 years, all right, or if the author has no problem, then we can put it. There is absolutely no problem. Go ahead, Surendra.
I have a question. So you are telling me, as opposed to what Anoop Jain said, that all the books he showed, they are in Hindi or in Sanskrit. On the other hand, you're saying other books exist also. Am I correct?
Yeah.
No.
So we're talking
about the source material available is either on mathematics, exclusive class. There are two classes of Jain School of Mathematics. The books related with the exclusive class of the Jain Mathematics. At source, they are available in Hindi and Sanskrit. Hindi or Sanskrit. Ganit Sar Sangraha of Mahavira, translated by M. Rangachari in English, and Ganit Sar Kaumdi by Thakkar Feru, which is translated by Sakya, a group of the person. It is available, translation available in English, and these two books are published. Rest of the books, the list which I have shown here, are not even translated. There is no question of being availability in English. So they are basically the Prakrit text or Sanskrit text or Hindi text. First they should be translated, then it can be uploaded.
And they are
hello, let me say one word.
They are the original.
Professor Mahdi, hello. What Praveen Bhai, it was nice to see you. And as I said, I am one of the great users of the e-library, which is doing great service. Now, let me add, L.C. Jain books are in English, but they are not still, as far as I know, on e-library. So those, and they are the great source of, at least related to karma theory. So that's one. And other is that PhDs, quite many in India as well as elsewhere, are in Jaina subject, but somehow or other, of course, there is a restriction, like everywhere, intellectual property or whatever. And I don't see these available again, whether it is Hindi or whatever the subject on e-library, like in mathematics and statistics. For example, my PhD students, their PhD are on e-library, and it's not on e, means in our university library. One can access a soft copy. So this is, sorry to raise this, but it's a great to see you, Praveen Bhai, and you are doing such a great service. I depend so heavily on it.
Yeah, I salute Praveen Bhai, what he has done. And Praveen Bhai now respond to L.C. Jain's work. How soon you will be, within a month or so.
7 volumes written by Professor L.C. Jain with the title Exact Sciences and the System Sciences. Exact Sciences in Jaina Karma Theory and System Sciences in Jaina Karma Theory. I have seen all these. They are the translation and explanation of Triloy Parnati, Trilok Sar, Jambudip Parnati Sangaho, Lok Vibhag, Labdhi Sar, and Chapana Sar text. So these are all, these texts all are of canonical group. Tiloy Pranati, Triloksar, Labdisar, Chapdasar, and Gomansar, they are Jain canons of Digambar Jain tradition. Therefore, I am talking about the exclusive class only. The work of Professor L.C. Jain, which is initially published in India under the mathematical content of Digambar Jain text of the Karnan Yog, and later on it is published in the 7 volumes as Exact Sciences in Curve Antiquity. I have all the volumes. I can show. Tomorrow I can show these volumes. So they are very important, but they are not exactly mathematical. They are not the exclusive class. They have a lot of mathematics. They have a lot of mathematics contained in Tiloy Pranati, Triloksar, Labdisar, Chapdasar, and Gomansar, and very useful too. So you can put it. If there is no issue of copyright, then it should be made available on the Jaina. There is no problem. But I want to explain this thing. They are not of exclusive class.
No, of course not. Thanks very much, Anupam Bhai.
I think this discussion can continue for a long time, but I think it is better that we continue in future, be in contact of each other, and that is the purpose of any symposium or conference, that you know what is going on. So to sum up in the end,
can I add a word, please?
There,
Dr. Mehta here from Toronto. Can I add a word?
Okay, Dr. Mehta.
We are on Zoom now, which is 21st century technology. You are all talking about translation in the 20th century way. The 21st century way would be all the books that Anup Ji talked about and more can be photographed. All the pages photographed. Then a computer analysis made so that each character is put in a proper form. OCR is called, optical character recognition. That way it will be so much speeded up. Then we use automatic translation that is done. Again, the speed of the translation will be very much greater. That is the direction we have to take. Not this ancient method of translating books, but getting the thing out, and then it is out.
It is already done. All English books are being OCR'd, and it is available. Every word they search it, not even books or title. Every word, there are 3,000 plus books are available. It is a new website we are developing. The website name is Jain QQ. Jain QQ, just a 6 letter. And then you put any word and you see how many books you got it. And that is the searching from word by word, not from chapter by chapter or title by title. So it is already taken care of all English books from e-library. And then now we are working on Hindi. Same way, all Hindi books will be searched, every detail of it. So you will see, because we are in the search things, we are very advanced. Okay, we have done it, and then now we are working on a Hindi one. But English, it is already done.
Thank you very much, Praveen ji. Now I think it is the time to sum up.
Okay.
In a couple of minutes. In all, there were 7 speakers, 7 presentations. I'll say that each presentation was excellent, undoubtedly, but the first 5 presentations, I expect that on the basis of the questions, queries, and comments, particularly from Pankaj ji regarding the comparison with Euclid's Element and other literature, I think all these speakers would like to revise their presentation. That's very important. And that is the purpose of this symposium, that you get the feedback, you get the queries and questions, and you revise your manuscript. That is what I expect. And I'm sure that Pankajji will expect the same thing, that now the manuscripts should be revised.
Let me add one more thing. I have placed most of those classics on a Google Drive, and I have made them available long time ago. All the Greek classics and other classics, on this maths, they are available on the Google Drive.
Yeah, Pankajji, that is what you have had already written in your white paper.
Right. In the white paper, I wrote down the summary of each classic.
Yeah.
8-page, very bullet, very.
That's right.
Very concise.
That's a wonderful white paper. Really, I enjoyed that. And regarding the talk or the presentation by Professor Balram Singh, why I was interested in mathematical modeling, because I also do the same thing. I could not really understand the philosophy and the theory which Dr. Balram Singh was trying to give, but I could appreciate one thing, that this philosophical ideas are being converted into mathematics, and that is the beauty of mathematics. I do modeling in atmospheric instability. And my approach is that I take lots of things in the beginning so that I can construct a model, and then I keep on improving my model. I hope the same thing might be being done in this modeling also. Then as the discussion was generated, Dr. Anupam's presentation was very informative, and I think each one of us is benefited by the information which was provided by Dr. Anupam Jain, Praveenji, and others. So it's my duty now to thank all the speakers for the work they have presented, for the hard work they have done in the presentation of these talks and lectures. And I hope that the tomorrow's seminar is also going to be very good. From my perspective, today's whole presentation was excellent, and I congratulate all the speakers. I congratulate Pankaj Kumarji, Sulekh-ji, Praveen-ji, Anupam, Surendra-ji, and those who are associated with this symposium. I know in the background there is a lot of hard work involved. I know that the team is working for many months, almost a year or so, and that is why it is going to be a great success. Thank you very much for giving me this opportunity. Thank you very much for all.
Thank you.
I think that's all.
Yes, thank you.
Thank you.
Rajbhai, you can play the temple.
Today's session now.